that we had to do like in 45 minutes.
I got 30.
It's just to a point.
30 minutes
Yeah.
to the whole thing.
Wait, someone sit over there.
Yeah, two of you guys outside.
Someone who goes to the toilet not so much.
I have to sit here. I'm gonna do this
Why
one.
you go?
Who's watching? No one's watching.
So
No one's
you must
watching. No one needs to.
The guy from Melbourne.
Brisbane.
Brisbane, yeah.
Does he watch?
He does.
What?
He does?
The guy from Brisbane, why can't you just like drive over here?
Every Monday? Yeah.
10 hours.
Mathematics extension.
Oh, right.
Actually,
10 hours. Yeah, you can do 2 papers in the car.
Oh, yeah, exactly. Like, you can do that all the
And
time.
10 hours of errand, that's the problem.
10 hours away.
Yeah, you can like do 5
Yeah,
papers.
you can make both of your parents and you can switch 5-hour intervals.
Yeah. So you're on your L's, and you could be a good 10 hours of driving.
Okay, so a binary operation is defined on all positive integers x and y that satisfy. Yep, defined.
He's explaining us the question.
So a binary operation defined on all positive x and y such that one.
Wait, this
Let the binary operation be start. Yeah. So
Yes. So x star x. So star is some kind of new operation.
Yeah.
So x star y equals
Well,
y.
it might be
So it's commutative. It doesn't matter what order you put them in. X star, x plus.
Yeah, so we all want to go with this one, right?
Huh? No, I haven't done that.
Oh, you didn't do this one.
No.
Which one
which
did
one
you
did
do?
you do?
I did like the first question.
That is the first.
Yeah.
no, this is the last.
What?
Is it the last?
This first one.
Which email? Did you get my email?
Yeah, but your email like you did the photos in a weird order. So I just something.
Yeah, I said Monday questions.
Yeah.
That was the first Monday question.
But you sent it last. It's like photo order.
So yeah, I sent that one before as well.
Yeah.
But yeah, focus on the more interesting one.
Wait, at your school,
So some says
Wait,
fine.
I think, do you still do agriculture? You do agriculture.
Yeah. So the question is find 11
I
start.
actually still do that.
Yeah. Okay, so we have these 3 relations. Okay, cool. Like 11 is like, okay.
Yeah. So
Show us the way.
So to keep. Maybe.
do you want me to show a solution on how I got this?
Find 11
So does
star.
that mean that x star y is not
You
0
should
for a
not
line?
in here, that's
Oh, x star y.
okay.
Wait, is x star y never 0? 11 star x. X is y.
Would that just mean there's another pile?
X is y.
Why? Is it for all real x or is it for like
All positive
Yeah,
integers.
exactly.
positive integers x?
What? So that's
Wait, so a binary
So
operation.
x and y have to be
It's
positive
not
integers.
business, it's a fact. It comes-
Okay.
X
So do you
star
want
x.
me to show you the solution or how I got the solution?
Let us know like some of the
Okay,
process.
If you do 1 star 1, that's equal to 1 plus 2. Equal to 2.
Yeah, like if you like x being
Yeah.
2.
Then you apply that to this. You get 1 star 1 plus 1 over 1 star 1.
So you did 1 star 1 equals
2.
1 time. What is this?
1 plus 2.
Yeah.
Oh, 1 plus 2 equals
So it's like this one. Yeah. Then this one is up. And then you get
1 star 2.
okay,
1 equal 1. Yeah.
so this is equal to 3. So
Yes.
1 star 2
Two.
equals 6.
Huh? Oh yeah.
Then applying this to that again, I think. Hold on. But then you get 2 star 1 is also equal to 6.
Yeah.
And then applying that, you get 2 star 2 plus 1 over 2 star 1 equals to 2 plus 1
Go.
over 1 3. This is equal to 6.
This is equal to 2
2
star
star
3 equals to 18.
18.
Is there a pattern?
There is a This is just a solution to get to 8 star 11. Anyways, so
Are you just gonna keep doing that?
I am gonna keep doing this.
So right,
So basically, you brute forced it.
I did. I need to figure out that 1 star 1 gets you to 8 star 11.
We can keep doing that once you get like 8, 9, and 9, 10.
No, you get no. They add together.
Huh?
Plus 2 star. Then you can swap this around. You get 3 star 5, and you can swap that around. You get 5 star. No, then you can third one's don't swap when you get 3 star 8.
You get.
Yeah,
So you brute forced it.
I did.
Is there a better way to do it?
What do you mean better?
I'm just wondering.
there's also the possibility of going from 11 and 8 backwards.
Yes. Star 8. So you don't actually have to find the star operation.
Is your method similar?
Yeah, just go like keep
Go
going
from 11 and 8.
from 11 to 8, just go like
8.
8 plus 3.
How about you guys? Similar method?
Sure.
Not all the way.
It's open.
Yeah, I know, we didn't get it.
We did some. Just kidding.
No, we didn't.
There's 164. 69.
Yeah, I guess you can only ask for a non-brute force way if you could solve it already.
So fast.
Yes. You should leave it.
It's just. Just kidding.
By the way, we just had our math test today. School math.
Good job.
Cool.
I made quite a few silly errors. Actually,
Is the answer like 264? Let's see.
Yeah, it is.
Hey, why are you doing that then?
What you
An easier way.
What is your
18, 2 times 3 times 3.
well, that's not time.
It will work though. 2 times 3 times 3 is 18, right? We have this. 3 times 3 times 8 is 72.
Times.
And so then I
It's
did.
not multiplication.
But it works. 11 times 8 times 3 is.
Because something more doesn't mean it's right.
Oh, interesting. Okay, wait. Well, that's a good idea. What
Two
would you
times
say?
times 3, but
11 times 11
Solution.
times 8?
the
Wait.
solution isn't 11 times 11 times 4.
No, 11 times 8 times 3. Just times 3.
Oh, so you do times them together and then times 3?
Intelligent move.
Oh, interesting. Okay, so 3 times.
That's how you.
But that doesn't work. But that doesn't
Alright,
work
hold on,
for
so
all.
wait,
Yeah, they do.
let's check if the rule works. Okay, yeah, hold on. So this is a good idea as well. So you're saying x star y is just x times y times 3? 3x y. Is that what you're saying?
What?
X.
Question
Yeah,
mark.
what I'm about to do is called a version of
Yes.
move.
What I'm about to do is a
It's like.
It definitely doesn't work for first one.
That
So it definitely doesn't work for extra x.
that wasn't me.
But maybe it's
Yeah,
the
wait,
difference.
what's that called?
Can I join?
And then what's that? I think it's
Can I go
5, 4, and
to?
6. I don't think
That's
something
That's
that
illegal.
That's
I don't
not
think
funny.
your thing doesn't satisfy this. Is it always times 3?
Yeah.
X times y times 3.
Wait, what method did he do?
Just times by 8 times. X times y times 3.
That's not exactly what he did.
Wouldn't that mean that x and y cancel x plus y?
But you do it a different way. This is very sketchy.
Super
sketchy.
What's
It's like the dark alleyway sketchy.
Yeah. Good anime. but-
No, just stop the
Oh. Well, this guy's addicted to that math loving. Smart anime.
Wait, so out of all the calculations you did, does it always satisfy 3xy?
I don't think forward.
And your one, the worker.
Based on the last one, I'm not charging by any constant ones.
Oh really?
Yeah, because
What year are you in?
so
Year 11.
if it's like if x star y is x y types of
Are you still in
constant,
year 11?
Yeah.
then the bottom is x y constant.
He's
On
lying.
top is
Actually,
x plus y constant. So the x and constant cancel out with the bottoms, and then you end up with
Come
x
on,
plus
this guy's
y and y.
not intelligent.
Oh.
You don't put
Any
past
of the
experience.
ones.
You don't put past experiences to like intelligent.
Yeah, only seven
Hurt me, number one.
I know.
So that's
but
what
I'm
the
just
second.
saying that you might not. You're in year
And I
11.
guess
you might
the
not
constant can depend on x and y.
He's not doing it.
Constant doesn't
Are
have
you
to be the
gonna
same.
say?
He's
So you don't
staying in
have
the
like
What cut sketching?
No, it's not. Nothing to do with
Yeah.
actual curve sketching.
What?
But like
What?
potentially, if you
What
did
are you
have a
talking
good
about?
idea with star, you could solve
I
it.
just said that actually shows the time.
It was star.
Yeah, I know,
Sounds like
it's
that.
like-
That would be a fake solve. I
When
think.
you say somebody's attractive, you say she's got good curves.
Yeah, but then
But like, she can also. It's a. Come on, you still don't get the joke.
I do get the joke. It's just not funny.
So the time.
You get the joke as cut sketching.
Yeah. So the first
I know
one.
it's not funny.
It's not fun.
It's really retarded.
How do you complete something? So was that?
Oh, and you got 264. Was that the answer? 264. Did you have a equivalent to that basically? Or?
Yeah, just one.
I need
alright.
Yes.
So the only reason I
I'm in
thought
the
of times
What
by
school
3
do you go to?
was because we had when I did my way, like my random stuff.
You got a random fraction.
Yeah, but it was divisible by 3, so I thought it could possibly do this.
Hmm.
Like,
But then,
It is
but
interesting.
then that little starting
Yeah,
of what it could be some random thing.
try it. Just
Plus
try it.
minus divided.
Just try it.
Yeah, that's how I got.
Bad
got-
guy.
Yeah, that's how.
You
X star X does not equal X plus 2.
Beta.
Yeah, it does.
Yeah, it does. No, it does.
That's a rule.
What are we talking about?
No, I mean, but like if you say
It's a
X star,
starting rule.
if you say X star X, Y equals 3XY,
Or maybe the rule
Yeah.
could be like, if it, oh,
so how come 3 star 3 is equal to 5? So 3 star
if-
2 is
You
equal
know,
to
X and Y are
IQ.
different.
It's just like staying in the class. It's actually unique answer.
What is this? If you what is this?
It's just staying.
I know, but to define the
Okay, you're
operation, right?
accepting paper.
You could define it separately from the ones where x and y are
Easy.
different. Right?
It's this year 12, no, 11.
And then you could define
What is this?
like the first one
that's
defines
easy. You just find a perimeter
what it
of
is
that
when
and
they're the
just
same,
substitute
right?
that in there and then you minus it.
okay,
I know. How do you find
and then you
Easy.
could use the
No,
second.
put-
You could
put
use
the coefficient
the
of
other
the
rule,
top and
3xy,
add one
to
and then
define it when they're different.
cancel and then you substitute them.
And then you gotta check that it satisfies those conditions
It's getting
and that they're not inconsistent.
Yes, you're in here.
Yeah, I had it. I'm kidding. I'm
Maybe that's the
I just
way.
know this stuff because I studied it.
This is an interesting idea. I don't want
It's got to
It's good when you study.
So what if? So you have an
I
operation,
didn't
right?
study here, right? And now I can't study.
If the two x's are the same, right?
Because I keep.
You define it
I
to be
keep
x plus
looking-
2, yeah? If the x and y are not the same, guys, focus on maths.
I am focusing on.
No, you're not.
So if x is not equal to y, yeah, then you can define it to be 3xy.
Wow. Mind blown. Mind blown.
Does that make sense?
Yeah.
So
Is
that's
it-
the definition.
So
right?
this is the piecewise function.
Where y doesn't like 4 times x y. Like, why would it 4 times?
4 times xy, it would probably would.
Yeah.
But I guess it's a fake solve.
Well, I was thinking, no more like, I don't think that actually.
I get it. It's a question.
I don't want to like, you just using that word, just like working in the problem. It's just a constant line, x, y.
Yes, exactly.
So you wouldn't actually get any line.
No, it's not
You
a
wouldn't get,
constant.
so you could actually choose 4xy and you get a different answer.
No, it's not a constant xy. It's dx, like
Together,
the x and y from the original. Wait, can you give us another 2 things that you
So
saw?
that's then why is that? So is there something wrong with the?
No, another 2.
So
No, it's
how do you
completely
show
based
the
on
function
nature.
inverse?
It's completely based on x and
Easy,
y.
you substitute x is y and then you
So,
just make y
because
subject.
eventually you get to like.
Just
in
give
that
me a
one, you
random
eventually
x.
get to one where like
Star y
x
that
is
you
like
solve.
3, and y is 3, and x is like 2.
Sure, 11:30.
But then
That's
so
what
then
you
you
have
get
the
like
x
x
for
plus
that?
y.
Yeah.
You get
Yeah,
like
11:30
plus y.
gets the same.
X is those get divided, you actually get a result.
11:33.
But then for stuff like maybe if they had a difference of 2, then they wouldn't necessarily end up like multiplying by 3.
Oh, so maybe this condition doesn't work. So look, check out this
Yeah,
condition.
that's
you let
it's a warm-up question.
you let y equal x, yeah. So maybe that's where it fails. So if you look at the so if you if
I'm gonna
Right.
do it next.
yeah, so the condition probably fails when
I'm
y
gonna do
equals
it in
x.
3 years.
No,
See?
what?
No, so I'm trying to see why the other solution doesn't work. Because if you just define an operation like this, right? On the x's that are the same, it's x plus 2. On the x and y's that are different, it's 3xy, yeah? If you just define that and it satisfied these conditions, then it would give you the same answer, right? So it clearly satisfies the first two conditions because we're kind of defining it like that, right? I think it fails the third condition. Okay? Because if you let y equal x here, right? Then the problem is you get x star 2x, yeah?
But it could be a piecewise function with a different value when the two sides are the same. X star x.
On x plus 2. This pen needs to be forward.
Yeah.
Yeah.
That equals.
So that doesn't always work, yeah?
Yeah. That equals
And that equals
2x.
yeah.
2x. So that equals 2. That equals 2.
That's oh yeah, for right hand side.
Yeah, so it's x plus x on x, yeah?
Yeah.
And then for left hand side, it's
So x star
2x.
2x equals 2x plus 4, yeah?
Yeah.
Okay, and so that means 6x squared, yeah? Equals 2x plus 4.
Yeah, that's not the case.
Yeah.
It's nowhere near solvable.
So you can't actually tell if it's like.
Yeah, so that's a good point, because you could put any constant here and it would sort of satisfy this if you didn't run into that problem.
And then there's only like the case that I created.
Yeah, so you still need to figure out something that works for this as well. Yeah.
Why does this third condition even exist?
What?
Why does the third condition exist?
Obviously not something.
Because like you're applying the same thing to basically that. You're just applying this
Yeah.
Maybe one
to
is
that.
But so far you haven't said anything about what happens between different x's and y. Yeah. They're different. You haven't said anything.
Yeah.
So for the
No, but it's literally just saying x plus y over y is equal to x plus y
You
over
don't
y.
know if it's this.
Because you're doing the
if you
same
cancel-
operation
You
on
don't
both
know if you
sides.
cancel x star and x star out.
yeah.
You can't necessarily cancel.
I guess yeah. So
You don't know if
this
it's
is saying it is like multiplication, sort of, but only in this way. Yeah. So I'm glad we had an interesting discussion about this problem.
And so are these the type of problems you're gonna see in the IMO?
AIMO.
AI, but the IM.
It's too easy for the IMO.
Okay. So yeah. So it is kind of like multiplication, but something goes wrong with the first property. Yeah. Okay. Good.
But like, what does the first property even do?
Let's see.
Let's you find and allow you to like solve the problem.
Wait, so what is the actual? Did they actually give a definition at the end in the solutions?
We'll just give you the first tree and say, well,
They wouldn't give you this. They can't give you the definition of this.
No, I mean, but in the solution, in the solution paper.
They don't give you the
The actual
solution
thing
of
might
the
not be
test.
fun. I mean, you're not supposed to use actual things.
Yeah. Alright, there'll be something after we do AIMO finished. I'll have interesting comments to make about like sort of lists of axioms. That'll be kind of interesting, but a bit beyond us
It's
right
actually
now.
so hard.
It's the axiomatic method. I'll talk to you about that
What's
later.
your
Okay, anyway, who wants to do the next one? It was
It's Sean.
Huh?
Yeah, I was just typing.
Which one?
so there was
I
either
didn't
an
do the next
arithmetic sequence of primes or in circles.
First normal plastics.
The primes one. So that's 09 question 10.
Oh, why is
it?
Yeah, I am so hard.
Is that 06 or
I think that has you can back
Fine.
okay? So I think it's
Like you have to get 1 to 8 correct.
And no, 1 to 7.
8,
1 to 7.
21 is not high distinction.
It is high distinction.
Yeah, so
It
it's
is.
09 question 10.
21.
22.
21. 21 is high.
No, it's not.
09 question 10.
It is.
21.
I mean, it's not the
From
same every year.
19 is high distinction in some years.
It's not the
Yeah.
same every year. Guys,
Yeah.
focus.
When that's level questions. It's in a range to like 19 to 24.
Alright, arithmetic sequence of primes.
Yes.
09, there's an 09 question 10. Does anyone do it?
No, but I'm happy to give it a try.
It was
you
a
do it?
question.
Yeah. You want to show us? Or having show us? Okay. Oh, you did it instead.
What is the force coefficient? of this game?
He did help me before I asked him if he did it, and I helped him. Like I gave him my hints, and I helped him finish it.
Okay, so show us.
What question?
What's the question?
Arithmetic sequence of primes. So Habib will explain us the question and tell us how he did it.
Did answer 5?
Yes.
Yes.
So the question is not about the answer.
Hey, you should have 5 and stick it up. The question.
If you wrote the 5 primes, then you would get maybe 1
Yes.
out of 5.
I mean, if you wrote 5,
No, if you wrote
you wrote
5,
it,
you might not
probably.
get anything. But if you actually wrote the 5
5
primes
primes,
and said 5,
Is
Yeah.
that 5, 11,
Might-
17, 23, 29?
I think I would prefer you if you said at least 5. Yeah. Alright.
yeah.
So what was the problem?
Okay, so basically the question is you find find the largest series of primes,
Sequence.
sequence of primes.
Series is like a sum. Yes.
In an arithmetic progression.
Largest sequence of primes. Is that like largest sum? Or
Longest.
the longest? You should have made that clear. Longest.
Alright.
Largest could mean like
Oh, yeah.
the largest number or something.
Everyone's a critic.
Hey, we don't criticize it.
Critic.
In an arithmetic progression with differences being difference 4 or 6.
Yeah, so I guess ideally this question would be phrased without using the word common difference or arithmetic progression, yeah, because that's cutting your audience down a bit. So that year, I guess they were just assuming everyone was in the crowd.
Okay, so basically what this means is like, in normal terms, it's like you have a group of numbers like a
Do you have to prove it?
plus, yeah,
Because I'm
It's a question that-
Oh, okay.
12, and then all of them have to be prime. So each one differs by 6.
Yes.
So the way
what
you
is
look
the
at it,
lo- well, of course, smaller primes have an advantage here.
yeah, but we can go on that later. But the idea here is if you see like they have a difference of 6. Since it's asking you for the longest sequence, then there's probably going to be some limiting factor that makes it like not possible to be like really long.
Really long, like 300 digits long.
Yeah, so
So-
for example, like one of the observations I made when I saw this was like, if you start with a prime, right, and you go another, like if the prime is p and you go another p terms, instead of not being prime,
yeah.
right, you're gonna get like 7p, right?
Like,
So every list is finite.
Yeah. So every
Also,
Yep.
isn't there like a point where, like after like there's not gonna be a prime for
Like 100
6
numbers.
numbers.
yeah, but like
But like that's very hard to
you,
prove.
you can't tell, you can't prove. It's hard to prove that kind of thing. Yeah, it's better to find something easy
Yes.
to prove.
So
than-
prove the upper bound in this question of the obvious upper bound would be like everything that goes. If you go 6 times, if you go p times that, the p will automatically be a factor.
Yeah. So if we like, so as we said, given the prime like starting
Given prime a,
then
if you go
the
p
sequence
times,
can't be the sequence must be less than
P.
p, right?
because it will become 7p.
So then, right, less than or equal to p, yeah. So then what we do, so that's like kind of a bound, but
Yeah.
if you go like a bit,
Depends on p, so it's
yeah,
not
if you go like for big enough, like if p gets a bit bigger, it gets kind of annoying to do. So maybe this isn't the best way to do it. So if we think about like primes, right? Then if we're thinking about like a series of numbers and them being prime, then we probably like the best thing to think about would be like it's like it's factors of the numbers. So
Also, they're
like the
all
prime
prime.
factors.
Big thing.
They're all prime, so they're
Yeah,
only.
Focus, focus.
So if we think about like so for the factors, they can't have any factors that they can't have any prime factors that aren't itself, right?
Yeah.
So like we can think of like it'll be helpful if we think about it in terms of like smaller prime numbers. So small like 2 is not going to be useful here, right?
Yes, of course.
And
Nor is
even
3.
numbers. That's what it is. Just-
Primes.
2 is not going to be useful,
So-
nor is 3.
So like let's try next prime number 3. So if we try to think about 3, right? We come with the problem. We come out with the problem because 6 divides 3, right? So if the starting number doesn't divide 3, then we can't tell how many of these next numbers. None of the next numbers will also be divisible by 3. So we can't use 3 either. So now we like move on to something like 5. So now 5 we actually can see something important here, right?
Because
So,
every time you add
Now we just
6.
do it in modulo 5.
Oh, I get it.
6
So-
is congruent to 1
On modulo 5. So the longest sequence have to be only 6. Because once you go 6 times,
It has to be less than 6.
yes, less than 6 or 5.
Yeah.
Because once you go 6 times, well, then you're
So
not
like
going to
we
be
can see
divisible.
that like
You're
since we're
definitely going to
adding,
be
since we're adding 1 every time, and there's only like 0 to 5.
You guys understand?
0 to
Yes.
4, sorry.
Wait, could you explain?
So basically, since if you
Yeah,
add to a prime 6 times, then eventually it will be at least one of those numbers is
Yeah,
going to
I
be
think one
divisible by
Basically,
5.
like the number you start with, it has some remainder when you have to divide by 5, right?
Yeah.
So I think 1 to that.
And if you keep adding 1 to that remainder, it eventually becomes 0,
So,
right?
then it will be not prime.
it will eventually become 5 or 5. Because it's the 6 is 1 or 5, you add 6 each time, it's adding 1 or 5 each time.
So eventually it becomes divisible.
And the smallest
Why?
one.
Because like yeah.
Alright, so now we know that like since there's only 5 of these, the
Maximum length is 5, and then
maximum equals 5, right?
and then it's simple cases.
So
5, 11,
Now like
17.
there's,
20.
like obviously we could like so the way we get 5 like
Is that
it's kind of hard. It's pretty hard to get 5 because you need the 0. So the only way to actually get 5 with having a 0 and it still being 5
Be
is
starting
if
with
you start
5.
with 5, right?
Right, and then there's
So then if you try it with 5, you get the series 5, 11, 17, 23, and 29.
I just started.
So like we can obviously know that 35 is not a prime.
Yes.
So that means like
So that's an example of the first case where it's divisible by 7p, right?
and then so now we see that like 1, 2, 3 like we know that the like case with 5 numbers is possible.
Yeah, so that's the first thing you thought of, yeah? When you saw it, you came up with the 5 sequence pretty quickly. So you know the answer has to be at least 5.
Yeah. So and like we know it's less than or equal to 5, and we also know that 5 is possible.
So,
So
it
then
must
the
be
answer
5.
must be 5.
So is that how you came up with it, considering the lower primes?
I just like immediately
I can suggest so more naturally. So from your point of view, hey, you came up with that sequence, right?
Yeah.
You come up with that sequence. You notice the next number is 35. It's divisible by 5 instead. Okay.
Yeah.
If you look at lots of sequences, actually, because this is actually showing that eventually is divisible by 5, right?
Yeah.
Because a lot of the sequences you see will actually be divisible by 5 or 7. If you come up with any sequence, it'll eventually stop being prime for the reason of dividing by 5 or 7. Right? Well, 7 is also minus, like 6 is minus 1. Well, well like, actually, it's kind of, yeah, so I thought of minus 1, 1, 7 first, then 1, 1, 5.
I kind of like P mode something. That's why I didn't think of
The problem with these IMO proof questions is they're so easy once you explain it to them.
No, because he's confident. He's confident with this kind of thing, so he can go straight to the general thing, right? Yeah. But if you haven't done it before, I think the sequences really lead you to the answer.
Yeah.
Right.
So
The
try
fact
small
that they
cases.
always end up being divisible by 5. They always end up being divisible by 7. But just if you try a random.
Pick a random prime and start adding.
Okay.
So one with 19 in it. What's one with 19?
13, 7. What do you know?
Yeah. So 7.
7, 9, 13, 19, 25. So that happens.
Divisible by
That's
5.
like one.
Yeah.
But we can do like 31, but then 30, like
38.
38, and then next one's like 45.
What?
Wait, no, 44.
Wait, 30.
What
What?
is
What's
this?
38? 37.
37.
37.
What is this?
Is it talking about 7 or 6?
37.
It's 6.
43. That's a prime.
So, 40.
And you had 27.
49 is not a
Wait,
prime.
what? And then 49.
So you divide
Why
by
did
7, yeah?
27?
Yes.
So, 49.
Why do you have 27?
It's no 27. That's a 25.
30.
Oh, what?
And then, yeah, so.
So the thing
Yeah,
is
no,
like, for there to be a short proof, what a short proof really means is that the reason why it's true is the same for all of them. Yeah.
Yeah.
And so in this case, the sequences all fail to be prime really quickly because it'll be divisible by 5.
Yeah.
Or 7. And then if you see that first, then you just have to come up with an argument.
Yeah.
So to express that.
And then once you do that, you just find one that works.
Yeah, and then you gotta find one that works to make sure it's not like 4 or 3 or
Yeah.
2.
So if it like, but I don't think like generally for these ones, finding one that works won't be that difficult because otherwise they wouldn't use it. Because if they were like, if it was hard to find, like the case you're looking for is probably in the first 100 numbers.
And definitely the first.
Yes, that's 100.
But then
Most
this is
likely
like a unique one, right? This one actually.
Pretty unique.
Yes.
It's a one-trick problem.
Oh yeah, because it's five, to get 5 numbers.
Yeah, no,
Oh
it's the
yeah,
only
because
one.
in this case,
This is the only
it's the
one.
only one that lets you do 5 numbers.
Because there is the
Yeah.
other ones will either the starting of it will be divisible by 5 or the ending.
Yes, this is the unique
That's the only one.
5
There's
solution.
only
one of
4
them-
in between two.
So because the only time you can have one thing divisible by 5 that's
Is
still
when
a
it's
prime
5,
is
yeah.
when it's 5. So
So the next
You
question
need
is very
to-
interesting. I don't know if you want to try with the in circles. This one, I think if you understand this one, you'll come to some conclusion that all in circle problems you'll be confident with.
in circles.
Because yeah,
What's an in circle?
in circles when you draw a circle inside the triangle, and the size of the triangle is tangent to the circle.
Oh, okay. So an X circle is when you draw a circle around the
No, that's
Circle.
circle.
Yeah, we took
But how do you question whether it's a circle, right?
Yes.
It's like 2 circles, it's like a circle.
Wait.
Oh,
There's a problem. Wait,
yeah,
there's a
that's
problem that
the
I've seen
the
that.
semicircle one with the.
Oh yeah, did you do that one?
Yeah.
I think we
Wait,
did
there's
that at some point.
a problem where you draw a circle, draw a triangle, a circle, and a
You
square.
have a shape
and
and then there's a
a
circle inside, so the
pentagon
circle
and
inside.
circle.
It's
Is
so
it
wild.
the? No. Oh, okay. No. What?
Okay, this is a pretty cool problem because I think it's cool because it's easy to state and
Hard to solve.
well, it's not necessarily
Depends, like you have to know it.
it's good to think about. That's the thing. Like it's something good to think about. Like some problems they're just messy. You don't want to think about. Them.
Oh, okay. It's like the ones that you have to try out many cases. And then it's good. Wow, this is.
So basically, you have a triangle ABC.
Yes.
You have a point D such that, and then you connect A, D, N. So the in circles of ABD and ACD are tangent to AD at the same point. And what they ask you to prove is that the in circle of ABC touches BC at D.
What?
Same point as well.
So
Yeah, that's also quite hard.
It sounds sort of hard, but
Yeah,
it sounds nice amongst the hard questions. It sounds easy to understand. It sounds harder to do, maybe. Doesn't this invite you to do it, as opposed to like give you 100 million side lanes, with 20 angles, and then
Asking you
asking
to
you
do.
for.
I'll just skip this question when I have to find it.
So you're
So-
trying to prove
that like this touches at D. Yeah.
Oh, so you're giving a triangle and you're given the 2 in circles, and then you're trying to prove the in circle of the big triangle itself also touches the
Yeah.
Yeah.
And the thing, so the circles have to touch the line at the same point as well.
Yeah.
Which is not that easy to do, I don't think.
That's why I have to draw something.
Yeah.
Or else we can have a Krypton case diagram dependency.
That was good.
Okay, so I think that's you have to draw the midpoint lines first.
The point line? Oh, like
Oh,
ones?
and these ones.
Yeah.
Yeah.
Like to draw them.
Because then you can get the sides that are actually
So
equal.
guys, do you know about in circles?
Yeah.
You know the center of the incircles is the intersection of the angle bisects.
Yes.
Or
They're-
3 or 2, yeah.
And a triangle's when you split a triangle into 6 parts with the three
divided.
It's always 2 to 1. So that's
Okay.
Oh wait, how is that? How does that work?
Same as that one.
I know, but like the lines are really bent.
why do you what?
Lines are really bent. So basically, you can see that each of them.
Guys, you guys will all understand the problem now.
So basically, one of the key points is that these have to be the same, right? Each pair of lines have to be the same.
These.
Yes.
So this.
So you basically have to prove how are they the same? Why are they the same?
Yeah, that's good.
So are these two? What are the sizes of the two sets? Don't know. So these have to be the same. So you literally have to prove that these three must all be
X, Y, Z.
3 pairs. So DA has to. You're not given the points that the other two tangents.
Do you want to label them?
Oh yeah, we should. EF. Yeah.
Okay. Do you want to label this one?
Oh yeah.
G.
Oh, okay.
G.
Yeah, two circles. Yeah, but you choose this one as well. Okay.
Yes, but it's the center of.
Sure.
Not really the center, but
Okay.
close to the center of
So
that.
this is the 06 question 10.
Today's the gift. That's really cool.
You can't prove
Are you
that.
guys following?
Zero,
Guys,
is equal to 1.
this is important because this really highlights, like if you see an in-circle question, it really gives you some insight into what to do.
I'm not seeing it.
So wait, does the E and F?
Wait, do you know that?
No, I mean these points. Are E and F those points?
No.
No, they're different.
Wait, is O that O as well? That O. Yeah.
No, so the O here is the intersection of
Wait, is that O?
No, that's not O.
So like the lines going from B and C intersect at the other X.
These are the.
What are they? I don't know.
But wait, those and then you have to mark. Those are the same as well. Like those lines.
These ones? Okay.
Yeah.
Yeah,
Those
sure. Okay, there you go.
No problem.
Because they're all very important.
Yeah, okay.
Those lines.
You want to label them like with variables or?
Label them with the variables. Yeah.
Yeah. Okay. So, what do you want to call this?
X. Length X, length Y, and length Z. So the wait, how's that? That's Y.
Dispose of the statement.
Oh, okay, yeah.
So then this.
And this is Y. That's Z, and that's Z.
what
And
about this?
this, let's call it A.
How many times do you call them?
Zero.
And
We've
then
got a double
I
because
swear I might have called them.
as A.
I found like 50 times.
No, it's because
Um,
if you
so
all,
I
basically,
you can't fall off.
now
Now,
since those lengths have to be really the same as
And then
each
I
side,
found the
they're the same triangle,
like this.
so that these 3 lines are all the same. This is
Yeah, but
equal
this
to
is
that.
also
That
fine.
is equal
Yeah.
to that.
Wait, do you guys understand why those are labels like that?
So in essence,
Huh?
do you understand why?
Look at the labels. So the point is, all the Y's are equal. That's why they're all labeled Y. Yeah.
Yeah.
If you didn't know they were equal, you'd write different labels, right? So why are they all equal? You know? Right.
Why? Oh yeah, because the tangent.
And you notice
Yeah.
you
So
notice
all those
that
triangles are congruent, right?
these
So the angle bisectors, the radiuses are equal,
equal
and the
to-
line's common, right? So all of them
Okay, do you
are.
want to label these or not?
on these, because we're not given any like information about
Yeah.
this angle, so it's
yeah.
So we're trying to induce.
Yeah, all of them are RHS. congruent.
Oh yeah.
Oh no, because you don't know this. You
Oh,
don't know
no.
the S yet.
So as in
The A and A.
The angle is 150.
Oh, well, that's like big. You know, it's the bisector because of our interest.
Oh,
yeah.
okay.
Okay.
Anything else?
So basically,
So guys, follow. If you follow properly, like seeing it'll be as if you did it. Okay.
and it will save me a lot of time because I'm being pressured with things I don't want to do, and this is not one of them. This isn't.
So you
So
want to do
just-
this?
Yes, I want to do
Focus,
this.
Maths, guys.
Maths.
Because
Focus on
I-
this. One. So you understand why they labeled that like that?
Yes.
Yeah.
Okay.
So now it's
But
now.
that's only used part of the information, right? The two in
Yes.
circles. Yeah.
Are they two? Are they two unit circles?
They're different. They could be different.
Okay, they're different. in
Well, they
length,
could be
but-
different.
But what do we really know about the radio? Well, we know the. We know the like. Is it of any value to try and work out the radii of those circles?
No,
Maybe for the investigation.
maybe.
Work out the circles because it seems like you could from the.
Can I point out? So look, if so, I'm not saying there's any different one way to do a problem, right? But if you do label the tangent lengths from the two in circles, right? That's naturally like if you're doing that, the natural continuation of that is to label the tangent lengths for the big in circle. Yes,
Huh?
that makes sense.
We already did.
No, this one.
Oh, okay. Yes.
Okay.
Does that make sense? But you're doing that anyway. Yes, you're just not doing it. You're just not fulfilling.
Can't you do the same thing right now?
You have to put the L0.
LRM. That seems random.
When you
Oh,
get
KLM.
So you have to prove
I guess you need another letter to B, maybe.
What's J?
Wait, what? D?
Like the second diagram. Maybe you need like another letter. Like D prime.
But do you
Yeah, okay, yeah.
wait?
Oh, because you can't like assume they're the same. You have to prove it.
this.
Yes, so you
Yeah.
can't assume that it's the same. So you have to prove that that thing L is equal to Z plus A and M is equal to A plus X.
Wait. I mean, since BX and CX are like the intersections, right? Doesn't that mean like this? The bottom of the circle.
M equals to A plus X. L equals to A plus Z and M equals to A plus X.
Oh wait, so that's it? Like, what? So you need to prove that L is equal to Z,
Z plus A. Yeah, that's what I said.
and then X equal to X plus A.
Yes.
Yeah.
So yeah.
Conscious.
No, they're not equal. No.
You have to prove that they're equal.
Wait, so
Yeah, so you're trying to prove
Uh,
that L is equal to Z.
First thing maybe we could know is, does this work?
Yeah.
Like, if this was D, would it work?
What? What do
Oh, that's
you
a
mean?
good question, yeah.
Yeah.
What do you
Like,
mean?
If this was this D,
Yes.
would this diagram be true?
Yeah.
Would this
Yeah.
example be true?
Why not?
Like, would the values work?
Yes.
Are you sure?
because
Like we're not given any
if you
numerical.
say that's Z A, that's Z A, therefore that's Y minus A, and that's X A, that's X A, that's Y minus A. Since those two equal those two.
Yeah. Yeah. So we know that if this was D, then this would be true.
Yes.
So that how do we show that if this is true, this is D?
Opposite. Just say.
Wait,
Is
what
it
did you say?
I look at the answer.
Oh, because this is the LK and M are only true in premise of D being true, so you can't use them to prove.
Well, yeah, and like it's the converse, so
Yeah,
it would
it's
be different.
basically saying like if you let M equals X plus A, right?
Yes.
And L equals Z plus A.
Oh.
Yeah. Does it check out?
Yeah.
Then Y would be K plus A, right?
Very scary.
Yeah. And then and M is K plus A, so then you get K plus A, which is Y, and then you get X, right? You understand? So that M equals X.
So what are some of the more
Yeah.
Wait, are there any
L equals Z.
are there
plus
any
A.
angles given? Angles,
Angles now.
are they of importance?
No. So like maybe an important thing from here is after you draw all these lines in, right? Like with the intercircles, you've labeled like a bunch of sides, right?
Yes.
And you also have a bunch of sides here. So this is probably not going to be a it's probably not going to be an angle question, because
Yes.
if you want to try to think angles, you're going to extend these two, and this is going to be perpendicular, and that's not perpendicular.
Yeah,
That's
so
just gonna be
it's,
a
the
normal.
angles are really messy.
Yeah,
so it's not.
you can phrase it in terms of angles, right? Because that would just mean you have to prove that's 9 degrees. Is that right?
Yeah.
Yeah.
Or the intersection here.
Yeah, but so having tried this, I got really stuck trying to do it with angles. Does that make sense?
Yeah.
So doing it with angles didn't lead anywhere fast. Or it may have led somewhere really slowly. Like it led somewhere really slow enough that you might try it, but get stuck. Like doing it, you know? So this is from trying the problem.
Wait, is there any property of having a? You see, notice the two triangles. Is there any property of having the sides a plus z, z plus y, and y plus a?
Not really.
Because if there is a property, you might want to take advantage of that.
So she's trying to prove that you know that
Is it like a proof by contradiction?
No,
Can you prove it by contradiction?
I didn't try.
what are you contradicting?
Or contradict that if it's not anywhere but D, then two
I
circles
suppose that might work.
can't be formed.
Not anywhere. Wait, what do you not do?
Yeah, I mean, yeah, I guess that could work.
In the end, it won't really be a contradiction. In the end, it'll just be like the actually, if you did that proof, it'll end up just being showing like it is D. Like it'll be contrapositive at that.
Yeah, I suppose you're like
What's a
saying like,
contrapositive?
Wait. How do you say?
What's a
it
concept
just works? It
A
works.
implies B. is
no,
the
but
same
like,
as
what if there's another way of working?
not B
It's
is
right.
not
You can
A.
be like, let's let that be y, man.
Oh, okay.
They're all
So
equal.
if A, then
It
B.
works.
That
But
means
like,
if it's not
that's
B,
one way.
then
So
it can't be X.
Well, I don't think you need to assume it's not B. Like if you just
Just
assume it's
perfect.
somewhere, you can show that the difference will be zero.
No place them. Make it short of yourself.
Like
Yeah,
it'll end up
that's
being
like-
true.
that's called the converse. So it's like saying if I am Leo, then I have 30 gigs of data. But that's not the same as saying if I have 30 gigs of data, then I
I'm
have
Leo.
Because I
But
have
it's
at
the
least
same.
30 gigs
But
of
it's the
data.
same as
Yeah, I'm not Leo.
That's so genius.
that. But it means if
That's
you,
like
you
a
don't have
perfect
30 gigs of
example.
data, since we said that Leo
Yeah.
has 30, so if you don't have it, then you're not Leo. But
Yeah.
you can't say you
That's
have
what
it.
I'm
like
saying.
Yeah.
That's not like that.
So okay.
It's my kind.
So how about we draw?
I like it.
How about we draw the something called?
My kind.
Yes.
Yeah.
How about we draw like an
Sure.
imaginary line here, and then call that like something, and then we prove it that equals 0.
It's kind of like I think that is good. Like,
I like it.
so I'll give you guys a hint. I'll give you guys a hint.
Why does it crack?
Think
Why
perimeter.
does it crack?
Think perimeter.
Perimeter of the triangle is half. Oh, you mean the perimeter of the triangle?
Yeah.
Oh,
What's the perimeter of the triangle?
Y,
It's
Z,
2y
Z.
plus 2y.
No, 2y, Z, X,
2y
Y, Z.
plus 2z
2
plus
X, Y, Z.
2z.
And what two X?
Why? What?
2y plus z plus x, right?
So what he's trying to say is he's trying to.
Oh, yeah.
So perimeter is like an invariant of the triangle,
Yes.
right? So like he's basically trying to show that the point D has to like the point of the contact of the incircle is uniquely determined by just the triangle, right?
So it doesn't matter how you draw the incircles.
Alright now, well, yeah,
I guess you kind of knew it was, right?
yeah, like
Yeah.
this is kind of like
It's just a
the
direct
definition
proof
of that, yeah.
Explicit proof.
So we know that like
So and also another invariant
that's-
is the triangle,
that's
the
unnecessary.
perimeter of the two triangles.
yeah, but let's run with it.
This question is actually so complicated.
But to see that it works is a big step in this
Yeah.
proof.
Huh?
Like knowing that it works means
It's a
like
big
you're
step to
convinced,
proving it.
you're convinced that like you're willing
At
to go
least
down
you
and
proved
try
it to yourself.
I mean, so you're basically proving that the point is unique now, right?
Yeah.
So I mean, think about how many ways you can describe the circle inside a triangle. There's only one place the center could be, right? And and then there's a shortest distance to the side, right?
Yeah.
And there's a unique point on the side, which
So
is the
is
shortest
it
distance
of value
to
to
the
draw this line to see it?
Also, you can also
There
do
is
Yeah,
short-
these. Yeah.
Yes, you have to join them. So and you can see that this is
It's fine. I think
It doesn't help anything because you don't
Because we
know
already
exactly
have
where X is in that thing.
Are they the same triangle?
yes. Then you're not following. Yeah, are you?
No, but he said he doesn't know what X is about.
No, I mean, but like X, you can't determine. They're
Wait, are you
both
saying that X
side.
is same to that X? Like, what?
Perimeter equals
maybe you could label that
KLM.
center of the inner circle
No,
as
it's
like
2KLM.
2K2KLM, right? Yeah. So that means what?
this could be important.
Could be.
Well, then you can equate these.
K plus L plus M is equal to Y plus Z plus X plus A. Whoa.
Well, if you equate these and then try to equate these two, the bottom line, then you get L plus M plus this distance. L plus M plus this distance. We're trying to the semi-perimeter
Yes.
equals to Z plus
He
2A
doesn't always watch it live.
plus X.
Yes, there is someone watching.
I'll see coming through the thing.
So look, this is the semi-perimeter, right?
We can ask if it's
So
him.
this
Maybe it's someone
is
else.
Z plus X, 2A plus X plus something, right?
How to be someone else?
I don't know. Well, it's just there. I didn't password it. I take it off once it's finished though.
I wonder who's watching. Some random guy. Just
Yeah.
Z plus K.
Type that
That's
in.
very important. That's equals to Z plus something. We don't know.
Yeah. So I mean, if you didn't realize, Hyping's trying to walk you through to the answer. He's not actually telling you the solution.
Yeah, that's
So,
very helpful.
If you guys aren't participating, he'll just tell you the answer.
Oh, okay.
What should this be?
Just put it as an array.
Could it be like might it be?
Oh, it's like the person left
Yes.
as soon as I said.
Because
What?
you're working out L plus M plus K. You don't know where this cuts. Yeah. You have to set it out.
It's probably him.
Like,
Wait, if it's not
like you,
He
the
wa-
idea
but he wanted
Yeah,
to-
mate, I mean more.
Yes. So
So-
L plus M.
Who else would it be?
Remove the plus K for now, but remember K is very important.
Yeah, right.
So that equals that, right?
Yep.
But then this means that K, the missing from K, right? Because we're given that K plus L plus M equals Y plus Z plus
Yep.
X plus A.
So what?
So this, let me
So
think
what
this
could
through.
that be?
So that means that if you have just L plus M, it equals this.
Yeah.
So if you add a K,
Okay, what
that equals to what's missing here? Y minus A.
yeah.
And then you
And then
well K, once you know this is equal to Y minus A,
Yeah.
you can cut a line here that's
Uh,
equal to that.
kind of like.
So you-
So we figured out that the K equals Y minus A, right?
Oh,
Yes.
well, that's it.
Wait.
How'd you get that?
Oh, okay. So
Well, you should be listening.
I am listening, but just
you were blocking it. You were blocking it.
Oh, okay, sorry.
So we know that like K, the perimeter is like this thing, right? So that means that equals that.
Yes.
So that means K plus L plus M. Right?
Yes.
But if we take just K plus L, right?
That's equal.
So K,
Y
L, sorry, L.
L plus
M, L plus M, right?
That's equal to.
That's equal to BC. So L plus M is equal to what's this?
L plus M is equal to Z minus equals X plus A.
Right?
Yeah.
Yes.
So that means K is equal to this minus this.
Yes.
Yeah, and
That
that's
equals
just
to Y minus A.
Y minus A.
A. Yes.
So like cancel. What cancel one of these, cancel one of these, so it's it's y minus a. Yep. Yep. So now we know this is k is y minus
A.
That makes it what's the fastest way from here to finding
A plus Z.
So what's this? Yep. Okay, good.
And then that's
That's
A plus-
z plus a, right?
And
It's
then
also
we get
A plus
we
C.
proved it.
And then that's z plus a.
That's what I'm saying. We proved it.
So then b
E equals D dash.
b prime equals d.
Yeah.
So the critical part is the perimeter.
Yeah.
Yeah, but that means that this is equal to that.
It's just so wait.
This is
Could you explain it?
Yes.
No, but this is also equal to that.
No, it's not.
Oh wait, no,
It's
it's
that
not.
M. That's M.
No, this is X. Sorry.
Wait, so you got the perimeter is 2K right?
Yes.
And then what is the output?
That's equal to this.
Yeah, I know. So then,
So then
So
you
and
have,
but you also know this is equal to that.
so you get KLM.
This is X.
Shut up.
plus-
So you know KLM
X
is equal
plus
to Y
Z.
plus
And
Z
then you
plus
X
have
plus
say
A.
if L plus M equals
This is X plus
A plus X.
Wait, what?
BC,
Wait, what?
right? BC is L plus
Yeah,
M.
L plus M equals
X plus A.
Oh yeah.
And then this is so you know.
And then you
A plus
substitute.
X.
So then
Yeah.
you know what K is in terms of A N.
Wait, so you get K plus L plus M equal to that, right?
Yep.
And then you get the
And you substitute.
L M is equal to Z plus 2 plus X.
Yep.
And then so you cancel it.
So
it's-
Y, so K equals Y minus A.
One question: how am I
Okay.
supposed to work this out without people walking through it?
Yeah, exactly. This is extremely hard.
It's
Exactly.
not extremely hard.
Exactly.
No. So basically, I guess so. The thing that will save you a lot of time with this kind of problem, after doing these kind of problems, is within circles,
right.
the extensions, the
The
tangents
tangents are
are equal, has been used like every time, and to great immediate success.
Yes, in circles, tangents are equal. The number one thing.
Actually, so the way I did this problem, I drew all the things in one triangle, and it does feel like it's maybe a bit.
And the
harder to prove.
And the perimeter is also very important because it's the invariant.
Well, perimeter. You get the idea of the perimeter after you find the lengths of the tangents.
I know. Then you equate the variables and
So
get it.
if you draw them all in one diagram, it works out equivalently. It might be a bit hard to argue at this.
Yes, it's very hard to
At
argue.
the
if you
moment
put
that
it-
you draw it, that like for example,
Yeah.
the radius meets it on the left of x, on the left of f, and it meets it on the right of p.
Yeah.
But this is such a genius move.
Yeah, I know. What I'm gonna do a back.
Only people
What
with
I'm
100
gonna
IQ
do
can
is called
do this.
we call a pro gamer
Only
move.
100. That's really small.
Oh, never mind. 200 IQ.
200 IQ.
Hey, mine's 139.
And mine's 100.
Well, mine was 130.
130.
It's probably gone down.
Is that
I don't know if it's better to have a higher IQ or a lower IQ. Relatively. Like I mean, because your achievements are the same.
Yeah.
Mine was.
And a lower-
They're just expected you not to.
No, but your IQ, your IQ is like, oh, it's like,
Your
your
IQ is
IQ like stays the same.
Yeah, I agree.
Like,
No,
it's
no, my processing
People are
speed.
smart. That means people around.
no, but then let's say your
I don't know where my diagram is.
your
I think
There's a would you rather
IQ
access.
also D.
Would you?
D
you-
and
your-
Yeah, but my
your
processing
level
speed is
staying the
equal.
same. My IQ is smaller because of the world of the toughest.
I got IQ 145 to 6, that's pretty good. I think I'll copy it, you can join my channel.
You gotta take it for the team, dude.
What do you-
Huh? What'd you say? Would you rather if you're
would you take one for a team of this week?
or just like no, honestly, if you were the smartest person in the world and you watch Cloud Hill, you'd probably kill yourself anyway. So like,
Wait, what? You're gonna kill yourself for what?
Because if you're the smartest person, everyone wants to understand.
and if you're the smartest person in the world,
Why,
and
why
you
would no one
understand
understand you?
Yeah, then everyone is just gonna be so dumb.
Yeah, think about how you're gonna live.
Yeah.
You're not.
Be the
Everybody's
second
gonna be
smartest
like, I
person.
don't
Yeah, just be the second smartest and talk to the first smartest guy.
Yeah.
Simple.
First one guys are kids of this.
And then yeah, because yeah,
because you're stupid. You're second smartest. You're not
Yeah, but the thing
smartest.
is, like, what if the second smartest thinks they're smarter anyway, and then it's like, just,
hey,
Exactly, because it's like the second smartest won't necessarily know who's the second smartest, because they don't give out rankings or something. You just think it's the smartest guy. It's like, oh, I know more than that.
Yes.
I would be the smartest guy before you.
God
Yeah,
told me
so
when
how
I was
I
born
can-
I was the smartest, so therefore I'm the smartest.
Nice.
Yeah, so I mean, if you look at the diagram, there's lots of diagrams that come out of this problem, yeah?
Send it to me. Let me try.
Okay, so I shouldn't have drawn this triangle.
It's like, honestly.
Perimeter is very.
So, like, we're drawing the circles first, yeah? So this is something you can work on, drawing the
Whatever
diagrams.
problem you meet, always think of the invariants first.
not always. Like
Okay, so you draw the circles first, yeah?
Some things you can go and learn, most of the time you don't.
Oh no, he's a creative.
And then you draw the triangle
Wait, why
for
not?
success with
He's a
triangles.
creative.
Oh, you draw the two circles first, so you don't have to mess
Yeah.
with the circles. That's actually genius.
Wait,
Brilliant.
how do we
Then-
access your live stream?
You can get it from that Udemy link.
Oh.
Yeah, if you click on a playlist, it shows the channel.
Yeah, but you
You
need
can
so the
subscribe.
live stream. Like if you're on YouTube now, you can just join the live stream.
No, we tried finding your name. Couldn't find
Really?
It's fucked up.
How did the other guy
But
find it?
once it's finished, you have to get the link. Otherwise, you can't get in. Okay, but you can actually draw this diagram entirely without circles as well, right? So if you just draw the triangles, and kind of just keep a few things in the back of your mind. You have a triangle, right? At this point D, right?
Or you can just draw
You can just draw the bisectors, right?
And then you can draw
So there's a bisector here that goes there, right? This one goes to here,
Everyone does.
Yes, you can go on the link.
goes here, and so then
So the circles aren't really
Where's the
important.
link?
Where's the link?
so these bisectors join.
Why are you not drawing the circles?
This is like the 2013 videos.
Oh,
Where is
Does this
the
make
link?
sense?
yes.
So you can get a diagram like this, yeah?
Yeah.
Guys,
Is that the proof?
Boy, I don't want
this is one way to approach the problem.
I know.
Can you see it?
Subscribers.
Subscribe to Amazing.
Are you you're not subscribing to my channel?
Yes.
Right, look at this. Look at this.
Well, that's
See,
all.
you can draw without the circles too, right?
Yeah.
You're just drawing all the angle bisectors, yeah. And the only extra information, I guess, is that these centers join each other, and it intersects at 90 degrees to the altitude-looking line, yeah. And so if you do it this way, then the goal would be to prove. Can you see that you're trying to prove that this is 90 degrees?
Yeah.
Or equivalently, you're proving that these two angles are equal.
So you're turning this into an angles problem.
Yeah, and then one of the sort of realizations is that it's hard to do it with angles,
Yes.
but it's really easy to do it with the angles, the line.
Hey, he's 69 subscribers.
Proving that those guys-
Huh?
How was
Oh, so we're trying to show that this is 90, right?
Oh yeah.
And I think this is already 90.
Wait, what?
And
Oh, yeah,
then,
yeah.
and then that's equal to this angle. And this is already equal. Yeah, I mean, so you're basically trying to show that dot plus this angle adds up to 90.
Oh, okay.
Yeah, it's already looking messy. It's already looking messy. Yeah.
Yeah. I mean, sorry, no, you know that dot plus that angle is equal to 90.
You know all the
And so to show that that's 90, you just need to show that that part's equal to dot.
What? What?
Because that part's common in between.
Okay.
Does that make sense? Because if you know this is equal to 90, so to show that this is equal to 90 as well,
Yeah.
and knowing this angle is the same as that one,
Yeah.
the same as showing that's the same as dot.
Wait, so what are you saying?
I'm just showing what didn't work. I don't know if that's like a valid thing to show. Showing angles doesn't work. Yeah. If you phrase it as an angle problem, you just show this angle is equal to that angle.
Wait, say
How
that
far
again?
behind this is? How far behind this is?
Wait, it's not that far.
Alright, I'm not showing this again, okay? So you gotta focus.
Okay.
You got the triangle, right?
Yes.
Draw the line in the middle.
Yes.
Use the angle bisectors to find the centers of the triangles, yes?
Uh-huh.
Wait, but the centers of the triangles are not going to be the centers of the circle.
Center of the circles, I'm saying.
What?
The centers of the circles.
Yes, no, because
How did-
these are
The angle bisectors intersect the centers of the
Oh,
circles.
okay.
I'm not talking about the centers. We haven't even defined what the centers of triangles are. Okay, so
Does
And
everybody-
then if these get extended, right,
so everybody have a different definition of the center of the
then
circle.
that meets at the center of the big circle. You know?
How?
Wait, what? So that's the center
Oh,
of
okay.
all the bisectors.
That
That's
makes
like the
sense.
center of all the bisectors.
Yeah.
Anyway, what's that one?
So this is the center of the big
Wait,
circle.
are the center of the
big
center of the
circle,
So that's the
bisectors are
intersection of
always
the
the center?
bisectors, right?
The centers of the
Yeah.
bisectors are always
Oh,
the center
yeah.
of the incircles, right?
And we're trying to show that this is the radius of the big circle. Yeah? Hello.
Bring it
Why?
back.
Why was it
Oh, you guys message, nice.
the centers of the bisect?
You managed to find it. Well done.
Yeah.
Is this on your YouTube channel?
Yeah, it is.
Yeah, but like it gets. Cause I only do it. Wait, is that you?
It's on my phone.
Anyway, it's like it's only public because it's easier to make it public when I put it live, but no one joins anyway. And then it's unlisted once it's finished. Yeah. Okay. No, don't do this.
That's going back to Josh.
No infinite mirrors. Okay. Okay, so you want to show that this is 90, right? Because you want to show this is the radius.
No, but
Okay.
Hello.
but the radius is tangent to.
Does that make sense? You want to show this is 90. Okay. And I'm saying this is equivalent to showing this angle is the same as this angle. Okay?
Ah.
It's because, first of all, these two angles are the same, yeah? Because
Yeah.
this is the angle bisector,
Yeah.
yeah?
Wait. Oh, yeah, I'm back. Yeah.
And then this angle and this angle are the same.
Yeah.
This angle bisector, right? So that means this is 90.
Yeah.
Yeah?
Mhm.
Because 2 times that
So
plus 2
then
times
that's
that.
also like equals wait,
Yeah, so and if you want to show that this is 90, right? If you want to show that this is 90, yeah?
Wait, not including that little part.
Not including that little part.
because that's all.
That's the same as trying to show dot equals, this is equal to dot,
Okay, how do you do it?
right?
Oh yeah, but don't you already know that's 90 equals tangent?
Huh?
Don't you already know that's really?
It is.
Yeah, because
No, because you're trying to prove that it's the tangent. That's the problem.
But
Yeah, I know, but you didn't join it to the point of contact. You joined it to D, right?
Oh, okay.
You know what I'm saying?
Yeah.
If you join it to the point, then it's 90, yeah?
Yeah.
And then you're going to prove it's the same as D. But here we join it to D and you prove it's 90. But I'm just saying, like, doing it this way was much more difficult, okay?
Oh, okay. So instead of what they've already defined the point.
So this has nothing to do with length.
Yeah.
But actually, you'll see that it involves showing. Actually,
Trigonometry.
this angle, I think, is also the same as that angle. So this will make this triangle isosceles here. Anyway, so it's much more difficult with just angles and no length. Okay.
Either way, G is smooth.
Okay, and then the diagram you can have with the tangents is you could draw in them circle, same triangle, yeah? So for example, you have the angle bisectors here. And then this is 9 degrees, yeah? And then you continue this one to this. And here's 9 degrees. Here's 9 degrees. And then here's 9 degrees. Yeah? And then there's 9 degrees. Here's 9 degrees. And then, so we'll leave this line undrawn. Yeah? Does it make sense? So basically, I've just drawn all the radii of all the circles
Yes, but
without drawing the circles.
That
right?
looks very weird.
Does that make sense?
Yes, it just looks very unsatisfying.
So I just drew all of them except for this one that goes to the, yeah. It's the same one. It's just 2 of them at the same time.
So I
So
think
basically
that,
the question is, where does this go, right?
I think that should really be the design of the new country's flag.
It's starting to annoy me. Okay, so D is here, right?
Yes.
So can you see that this is equal to this, yeah? This is equal to that. This is equal to that.
Yeah.
Maybe you can call this Y, yeah? If you call this Y, so these are joined together as well, yeah? Sorry, I'm joining all the. So then you can see that this is equal to y and this is equal to y. Yeah. You agree? And then I have here, this is x and this is z. Right? Is it clear that x equals z?
X equals Z.
Yeah.
Yes, it is.
Because it's from this
That's not it.
yeah, so from this center, right? This length here is equal to sorry, from this
Circles not.
at x equals z. Oh. Yeah, okay. So this is the middle line here. Yeah. That's equal to z plus that, yeah? See what I'm saying? Let's call it w, yeah? I'm saying z equals x. Alright? So the point is z plus this thing that's equal, like dot dot, equals w, right? Which is equal to x plus.
Oh
Do you agree?
yeah.
Yeah? So z equals x, yeah? So can you see wherever you put this point, right? You have like x plus that has to equal that plus wherever you put it, yeah? Right? So that means y has to be like you have to put this point somewhere here, right? So that this is x, right? Does that make sense? Well, if that's x, then the rest of it is 2y minus x, right? But for that to be 2y minus x, well, the problem is it's got to be equal to this plus 1, 2, 3 has to be equal to 1, 2, 3 plus x, right? So that means 2y minus x is also equal to x.
But why do it this like really complicated way?
But see, that's what if you're thinking this is more complicated, you're not understanding it. It's actually exactly the same way. I just drew on the same diagram.
What? It looks kind of. Because it's only one diagram. Yeah.
Yeah. So basically, this way, all I did was I just drew a triangle, right?
Yeah.
And I found the 3 centers,
Yeah.
and I drew all the radii in.
Oh, then you drew
Yeah.
a triangle in the 3 centers of the 3 centers.
Yeah. So I drew all the radii except for the one that we don't know, right?
Yes.
Not cheese.
While you're in the toilet.
What's genius idea?
Do you understand what I'm saying?
Hey, never makes sense.
Genius.
You don't understand what I'm saying.
Genius.
What?
So the point is, once you draw all the things in, right? This is x, and this is x, right? So I mean, you have to pick a point here, so that somehow this gives you x over here and x over there, right? But the only point you can pick is the midpoint of this 2y length, right? Because
If you pick somewhere else, then it's not going to be equal.
yeah, because you need this to be x and x, right? You need y to be equal to x.
Oh, because we just it's the same. It's like y plus a.
Yeah, because when you put this here, right, whatever goes here has to equal here, right? So then this part has to be x, right? And the same thing here.
So why do we
this
put
other part
x
has to be
in
x
the
as
first
well.
place? Why didn't we put that as x in the first place?
I mean, we don't even have a line here in the first place, right?
Oh,
I'm just trying to show you how like it can't be like there's only one point that you can put it, and it has to be in the middle, and it shows you the y equals x.
Yeah.
Right? You have to divide this interval in half.
When you said that 2y
Okay.
minus x equals
You have to divide this
y
interval in
equals
half, and the point is d already divides it in half. Right?
so D is the only solution. So that proves it.
Yeah. But I mean, you might want like if you want to like think about it a bit more, you might wonder, well, why does this point have a point radius touching this point that's on the left of this point? You know, like is it obvious that the center is above the centers of these two circles, and then the
It
radius
should
touches
be
there?
obvious. It should be.
Yeah, I mean these kind of things probably won't lose you marks in the text, but you might want to think about them.
It
If you want
should be obvious because there has to be like another. There has to be space for another support top.
Okay, you guys understand this question now? Yes?
Yeah.
I mean, the basic point is when it comes to in circles, using these tangent things are very useful. Yeah. And if you don't understand, you should really try it yourself, okay? Because like it's startling how you can understand that first proof, and then once the two things are in the same diagram, after you've understood the proof, you may not be able to understand this. Okay, so this is a problem.
It just feels like a mess of lines. But yeah, I can see that. Like basically, instead of drawing in the circles, instead you prove that they're equal. So
Yeah,
because
I mean, we just chased around the tangents.
because originally the circles are here and here, so you knew that this is equal to that.
Yeah.
But this time you don't draw in the circle, so you don't have to prove that happens. So you do it in the inverse direction, basically. Because you prove that these are equal, and therefore there must be circles here, and they must touch it at D.
Yeah, so I guess what we prove is that D divides this interval in
Yes.
half, and we need the point to divide
To
it
be in half for
Yeah.
the circles to form. So instead of proving that the D will be divided in half because of the circles, you prove that because of the triangle, the D has to.
Yeah.
You have
But we do show that it does divide in half.
Just
Love that same thing.
Okay, this is
what's the next problem?
That's it.
imbecile.
You should like it.
okay, I don't know, guys. There's lots of other problems to try. So
Yes, because in circle base. Why don't you have in circles?
did you guys try this problem?
I feel like
2011 question 2. Did you try this problem?
Hey, hi, Peyton. 2011 question 4 doesn't make sense. What happened?
if you don't think that one,
I am depressing.
He looks
find the number of solutions
like I thought you were like
x and y.
Oh, that was crying.
Wait, why is the 2-mark question such a big block of text? Wait, why is
Oh, I did that one. I can do it, I think.
no, I mean like it's such a big.
So the question asks you how many positive integer solutions there are.
Yes.
I guess it's a standard question of the theory, so I kind of just want to like talk about sort of what are all the solutions.
Because like that, I haven't done really any Diophantine equations.
Integer.
Wait, what are the tips of doing Diophantine equations again?
Well, this is a standard one, so we'll show you exactly how to solve this one. What are all integers x, y such that
Someone is supposed to evolve. Someone is supposed to evolve. That's on the comment.
huh?
Nothing
Was he the first one to comment? What? Yeah, he was.
else.
He was the first one to comment. You.
Not me.
I was second.
No, yeah.
Okay, so what are all the integers x, y satisfying
Oh, yeah.
this equation? Yeah. Okay, so this was part of the theory.
And then I
Okay,
was like, hi.
Go ahead.
Like smiley face with
so this is part of the theory. Yeah.
Yeah.
So I'm basically in general we talked about solving these equations for integer solutions. Yeah. So basically the one in the theory is. So I'm going to use this as an example to help you do the one in the theory. Yeah.
Yeah.
And I mean, yeah, when standard questions come up, it's always disadvantaging the people who haven't seen the standard problems. Yeah, so that's why you shouldn't really have standard problems in maths competitions. But this was a long time ago. Okay, so the way
that won't really pop up again in this year's.
well, who knows? There's lots of standard problems popped up last year. Well, variants of standard problems, which I guess is no one's standard. So yeah, can I just show you? How did you do it?
3x equals 2000.
Oh, okay. So you're actually just treating it like this. So I'm telling you the theory way of doing it. Okay, so basically you look at 3x plus 7y equals the GCD of 3 and 7.
Oh, so like greatest common divisor. So that's
Does this make
1.
sense?
That's 1.
So I guess in this case it's 1, yeah?
Yeah.
So we solve this equation first. So we solve this equation first, yeah? Alright, I'm not repeating this by the way, so you're gonna look up on the video. Okay, so we're trying to, huh?
Like a video on this?
Yeah.
It's recorded.
Okay, so we're solving this equation first. Whatever the GCD of 3 and 7 is, we put here, and we solve it, okay? First of all, if the GCD of 3 and 7 does not divide this number, then obviously there's no solutions, right? Because if something divides this and it divides this, it has to divide that, right?
If it divides this, if the GCD is not well, oh, so if you have something like 4 and 6, and then the
This
integers
is
that's
not is
odd.
odd, yeah.
So that
So that's no
obviously-
solutions, right? So the GCD of 3 and 7 has to divide this number for there to be any solutions. Okay? Okay. And then we solve this equation first for the GCD, and then we convert it into solutions for that. Yeah? Okay. So the way you do this kind of problem in general, you take the GCD, there's a GCD algorithm for 3 and 7. So for example, you can do 7 equals 2 times 3 plus 1. So it's a division algorithm, right? So it
Like-
equals 2 lots of 3 plus 1
like we
remainder.
did in primary school.
Yeah. And then you continue it with the remainder, okay? So then 3 equals
Two.
you know, 3 lots of 1. So it's actually finished, okay, plus
Yeah.
0. So it's actually finished already, basically here. And I guess the point is, when it finishes here, this thing will be the GCD, okay? Okay. All right. So then we just look
Wait,
at
so
this
that's
last
how
time.
you find the GCD.
Yeah. And then you see that 1 now is equal to,
So sometimes the GCD won't be obvious.
yeah. So this is an algorithm that will find you the GCD. And actually, if it had a few more steps, the process will be the same. You just got to keep plugging into the step. Okay. But look at here. It's telling you what 1 is. 1 is equal to -2 times 3 plus 7, right? Does that make sense? So that's a solution to this equation, isn't it?
But you can't have negative numbers. So.
What do you mean? I'm saying integers.
Oh, all integers.
Yes. But we can get positive numbers anyway, yes?
Oh, I
The
thought
point
you
is we
said.
have-
I thought you said all positive integers, but that bad.
The diaphanty means integers, it's not positive, yes? But
Oh.
that question it meant positive. But diaphanty means integers. This has
Oh.
nothing to do with positive integers. Okay? Okay, so can you see a solution for x and y is -2, 1, yeah? So that's a solution. Because 1 equals this, which we got from this, then x equals -2, so y equals 1 works. Yep? Does that make sense?
Yeah.
And so to get a solution to this equation, you just times everything by 2011, right? So if you times this by 2011, it equals 2011, right?
Yeah.
Yes? So then the solution for the one with 2011 is just x equals -2 times 2011, right? y equals 2011. Does that make sense?
Oh yeah, because it's negative 2 times 2011. Y equals that's negative 6 times 2011.
Yeah.
So 7 times
That solves an equation
2011. Yes.
at least for one pair of integers, right? So how do you get all the other solutions?
But isn't there like an infinite pair?
Well, I'm telling you how to. What?
There isn't. So there isn't infinite solutions.
Well, I mean, there are.
Positive integers.
There are if it's just integers, right?
Right,
Yeah, but in this question it's positive. Yeah.
Maybe you're right.
Yeah, I know, but I've explained this very clear. Like I've said this so many times already. I'm saying I'm not solving this question. I'm trying to use this as an example with all integers to explain the theory. Yeah. So yes, in the question it was positive integers.
So once you get a base case, you just have to add plus or minus, like plus 7n or something.
Yeah. So then you finally you have a 3x plus 7y equals 2011, right? So here it was minus 2 and 1. Here is minus 2 times 2011. 2011. Yeah. Okay. How do you get all the other solutions? Well, you can just see if you have one solution, say like call it 3x naught plus 7y0 equals 2011. You can get all the other solutions by doing
X
this.
naught plus 7.
So
Y
x
naught
naught plus
plus
7a. So it's a multiple of the 7k maybe. Okay.
Y naught minus 3k.
Y naught minus 3. Okay, yeah. You see that? So you can actually, so it doesn't have to be 7 and 3, it has to be 7 over the, well, maybe you can figure out what it has to be if they don't have GCD1. Yeah? So can you see if that works, then these all work as well? Because this is just 21k and that cancels with this 21k. Yeah? See the 21k and then it cancels with this 21k. So if you get one pair of solutions, you get infinitely many solutions. Okay, in this case, they're all the solutions. They're of this form. So I'm saying if you can find one x and one y to make this true, right? Then you can find infinitely many because you can just always add a multiple of 7 to this x and subtract the multiple of 3, the same multiple of 3 from this y. And the point is the 21k cancel. Right? What is this? This is 3x0 plus 21k plus 7y0 minus 21k, right? So this part already equals 2001, 11, and this part cancels, right?
Yeah. So this always.
Yeah, if the GCD is not 1, then you might make this like 7 over the GCD, and this is 3 over the GCD. And you should get all the solutions.
So
Okay.
if they ask you a question like this,
Okay. Yeah, so if you want to convince yourself all the solutions of this form, right? Think about if you added something to x, what the remainder would be if you divided by 7, for example. Okay? Yeah, anyway, and the reason I was showing you this, right, to find the solutions to this equation, I guess it's nice to complete it, but just the existence of solutions is enough to what we need for the theory. Yeah. Okay, because the thing that we wanted for the theory was But this was very useful in this exam or many situations. So whenever a prime divides a product, right, of numbers, see, so it either divides one of them or it divides the other one. Yeah. So this is really useful.
Oh, okay. So when prime divides a number, it can't divide both.
It can, but it gets inside one of them. That's the point. Yeah.
Oh, it has to divide one of them.
Yeah.
The mathematical definition for OR is it can be one or the other.
Inclusive or yes.
Inclusive.
So or both. Yeah. And the point is, if P divides AB, but P does not divide A, right?
That means P has to divide B.
Well, the point is GCD of P and A is equal to 1, right?
Yep.
Yeah. That makes sense? So there's a solution to PX plus AY equals 1. We just showed that, right? Okay. And if there's a solution to that equals 1, okay, and you sub in, you times it by B, right?
Yeah.
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 Then can you see that this is divisible by P, right? This is divisible by P because AB is divisible by P. Yes? So therefore this is divisible by P. Right? So this is going to be very important and helpful,
Oh, so
especially
that's
if you need
just
to prove something.
Oh, so that's just the proof for the above, right?
Yeah.
Wait, what? So P is
So this is the claim, yeah?
Yeah.
Yes, it's kind of like a lemma, but it's so useful. It might be called a theorem.
Oh, like it's the P is if the theorem we're trying
So
to
this
prove.
is P prime, yeah?
Yeah. P is a prime number. If it divides into AB, then if it doesn't divide into A, it must divide into B.
Yeah.
So you can prove it because P and A has a GCD of 1.
Yeah, because it's
doesn't
prime,
divide.
right?
yeah.
Because it doesn't divide. So now we know that PX plus AY equals 1 has a solution.
Yes. So there exists
There exists-
X and Y
because
integers.
I think P divides A and B.
Yeah.
Oh, so yeah, obviously because A and B don't have a common factor, so then P.
Oh no, A and B could have a common factor.
Where should A and B one?
Huh?
Because
A and B could be the same. So this is a common consequence of this. Okay. So if you look at, so if you have a square number, prime divides a square number, yeah. P divides A squared, right? So according to this, that means P definitely
has
divides
to
A.
divide by A.
Yeah. And
The
if
square
P
doesn't-
divides A, then P squared divides A squared, right?
wait, what happens if P squared is greater than A?
It can't be.
P to the 4th divides A to the 4th.
That's the nature of this, right? You can't have just a single prime inside of A squared.
Oh yeah, sure. Because P divides A squared, that means if you root the thing, P still has to divide A. Oh, so it's a common consequence because if P doesn't divide A, then it must divide A, so it has to divide A anyways. Because or else there's a contradiction.
Okay. So this will be very useful in questions
okay.
of primes.
Okay, dividing into stuff. Because P, for example, if you have, so you said PA squared, so the contradiction is that if P doesn't divide by, you said because of P divided by A squared, it must divide by A, because if it doesn't divide through A, that means it can't divide through A.
Yeah.
But it must, if it doesn't divide through A, that means it must divide through A, because A squared is equal to A times X, which is a contradiction. So,
Okay, so and this is the key part of the proof of the fundamental theorem of arithmetic, right? Everything has a unique factorization into prime, up to order.
every single integer.
Yeah. So I can show you quickly a proof. So every
integer.
n has a unique expression as a product of primes if you don't care about the order, right?
What do you mean it doesn't care about the order?
So 2 times 3 is the same as 3 times 2.
Oh, okay.
Okay, so I showed this before. So the first step, I guess, so I showed you different ways of doing the first step. Everything is a product of primes. Okay, so you could just keep factorizing, right? But maybe a nice way to write it down is you can say that, like, if it's not, assume it's not everything's a product of primes. Then you can find the least one, right?
Then there must be a minimum. And is that minimum a prime? Well, if the minimum is not a prime, that means it can be divided by another.
Then there's a smallest, right?
Yes.
The problem is the smallest n is not prime, right? Because
Yes,
a single
'cause-
prime is a product of prime.
Yeah.
It's a trivial prime.
Because you said you didn't have.
But if it's not a prime, then it's a times b for smaller a and b, right? But since this was the smallest that was
Then
not a
that's a
product, then these are both products, right? So a product of things which are products of primes is also a product of primes. Yeah? So this is a contradiction. Okay? And then the uniqueness is what uses the other result. So the uniqueness is interesting. So if you have, like, for example, if you have like PQ equals like the P1 Q1 equals P2 Q2, right? You want to say they're unique. Or you can say even R2 here as well, right?
R2? What's that?
That's a prime. Let's say they're all prime, yeah? And we're trying to show that this might be a contradiction if R is a prime, but we can show this may be equal to 1, okay? So if P1's prime, right? That means it divides this, right?
What's P2? What does P2 mean?
These are all primes.
Oh, okay. So
let's say we have two different expressions with the same number as a product of primes.
Oh, okay. So we're
Yeah.
contradicting. If there's like.
Yeah, or we're not necessarily contradicting, or we are if we have the R.
Oh,
Okay, all right. So P1 divides this, right? Yeah?
Yeah.
It divides AB, right? So it has to divide one of them. So if they're primes and it divides one of them, it has to be equal to one of them, right?
Yeah.
So then they're equal, say it's equal to P2, then you can cancel them. Right? And then these two are equal as well.
Yeah.
And no matter how many you had, you just keep canceling them like that. So it's a unique factorization of primes. That's called the fundamental theorem of arithmetic. If you can understand that, that'll be all we need to know for number theory.
Oh, really?
Yeah.
Arithmetic.
That's all we need for number theory for AI.
That every number has a
Huh?
unique factor.
P plus Q? That question?
Yeah.
Oh, okay. I'll quickly go through it. Huh?
Huh? Wait, what was
Yeah, this solves it, right?
Yeah.
So this is a good point. So I can't remember what number the question was, but it was I did it in another
question 9.
but PQR.
Yeah, that's it.
So the question is P is less than or equal to Q is less than or equal to R primes, yeah?
Yes. So what are we proving here?
Let's go.
Find the largest value of P plus Q plus R, right?
Oh, so there is an upper bound to this value.
So that equals square.
Yeah, we'll find it. Let's see if we can find it, yeah? The largest value. Does that make sense? Oh, and this is a square number?
Oh, okay. Oh, that makes sense.
Yeah, sorry.
So this has to be a square number, and now find the largest value. Is that the final? Is that a final question?
A can be P or Q or
Yeah, we have to do something.
Wait, is the a squared the square of a prime?
Huh?
Is a squared the square of a prime?
Oh no.
No, it's just a square number,
Oh,
right?
If you assume that P plus Q plus R is like
See, for example, like, P divides a squared, right? So we just did that just then. So therefore, P squared divides a squared, right? So
Q divides a squared, and R also divides a squared.
because when you square it, there has to be another P that comes, right? So the P squared divides a squared. So that means P divides this, right?
Huh?
If P squared
okay.
divides
P
a
squared
squared,
divides a squared.
then P has to divide this.
Yeah.
Right? So if P divides QR, right? So P either divides Q, P divides R, or P divides
divides
P
A
plus
P
Q
s-
plus R, right?
P squared. Right.
That's what we just learned, isn't it?
Yeah.
Okay.
P can't.
Wait,
divide
how
R.
does P
P
squared?
can't divide R. If P doesn't, if P divides R, then it has to divide Q.
Because then they'd be the same, right?
Yeah.
Because
Q is squeezed in between.
Yeah.
So P divides R, P is equal to R. And so therefore Q must be equal to both.
Oh, okay.
Yeah.
So if P squared divides A squared,
Yeah, so basically there's three cases to consider. R and Q are different, but these are the same. They're all the same. Or something happens like this. Okay. I think this is something you can continue on yourself. I don't think I necessarily have to tell you how to work this out, right?
yes, we could continue.
Please
this.
help us.
Yes.
We could continue.
Yeah, okay. I mean, assume they're all the same, for example, right? If they're all the same, what do you get? So this case says that they're all the same.
Oh,
Yeah.
if P divides R,
You get-
that means P, Q, R are all the same.
Yeah.
So
you get 3P.
Then it's PQ, right? Times 3P.
3P equals
is
A
not
squared,
possible.
which
A
is
squared.
impossible.
Because 3 is
4,
not.
that's 3P to the 4.
Three's not
equals A
There's
squared.
5 primes here, and there's an even number of primes here. Yeah. By the fundamental theorem. Okay. So that case is out. Yeah. Okay. P divides Q. That means P equals Q, and it's only interesting when R is not equal to Q. Right. So maybe like strictly bigger than Q. Yeah. So then we have P squared. Can you guys think about this as well? So P squared, I guess maybe just listen, okay? P squared R.
So how did you
times
prove that?
2P
How
plus
did you
R.
prove that when P squared divides A squared, that has to divide the other bit as well?
So now you're interested in that. Which part?
P squared,
So P squared divides this, yeah?
yes,
So P divides that, right? That's one of the P's.
yes.
So the other P has to come from the other part, right?
Okay, yes.
The one,
Oh, okay,
There needs
so-
to be 2 P's at least.
Yeah, so
of them's
P
there, the
times
other one
something,
has to be
the other
here.
has to be here.
But isn't that just if P divides two numbers, then P has to divide one of them? And since it's one of them, it's like.
Oh, so-
Exactly, we showed that, yeah.
Yeah, so either has they
So
have
we
to
didn't
be
agree
Q-
this is true,
yes.
right?
Yeah. So it's P divides A.
P divides A, and that's the in between.
It either
step,
has
yeah?
to divide Q, divide R, or divide the P plus Q.
P
plus R.
divides A goes in between. And then because there's 2 A's, that means there's 2 P's,
And
right?
it can't divide R because then they'll be all the same, and we proved that's impossible.
Yeah.
So now, can it divide P? Then can it divide Q?
What? What divides Q?
P.
Yeah, that's the case we're considering. Yes? So there's 3 cases, okay? P divides this thing, right? So therefore it has to divide one of the 3 things, yes?
Yes.
Q, R, or this. We consider what happens if it divides R. Then it would have to divide all 3.
So that doesn't work.
We've already cancelled this out, yes?
So
Wait, if
now,
you divide R, then why doesn't it divide Q?
Oh,
because
because
Q is
P-
equal. So
Q is-
if it divides R, then P and R are equal, right?
because they're all primes. You can't have
Wait, can't.
because
okay,
a prime divides another prime,
Like
then
Q-
they have to be equal.
And then Q is in the middle, yeah? Okay. So then we look at what happens if P divides Q, yeah? If P divides Q, then P equals Q, right? But we're assuming R is not equal to Q, otherwise we already covered that, right? So then we have this, yeah? P squared R is 2P plus R, yes?
So well, you can cancel. You can slash off the B squared. That doesn't matter.
Yeah, so the P squared is good because
because
that's already squared, right? But now we have an R problem, yeah?
yes, we have R squared
So,
plus.
so we need this. So we need R divides 2P plus R.
Yeah.
Yeah. Because we have one R, but we have 2 R's, right? It's a square.
Wait, what? Wait.
That means 2P.
Wait, how does 2P plus R divide? How does R divide?
Okay, so can you see that R divides B squared, right?
B.
R divides B squared, or R divides A squared. Yeah.
R plus R, wait, doesn't have to.
Yes. So R
Yeah.
divides this because A is equal to R times stuff. Yeah.
Yeah.
So therefore R divides A.
Yes,
squared,
if
yeah?
it were to be true.
So therefore
this
R
equation-
divides A. Yes.
Yes.
Wait, yeah, sure.
So then
So
R
then
squared
2P
divides A squared.
2P plus R
Yes.
must also divide A.
So that means R is not dividing any of the P's, right?
Yeah.
So another consequence I could say is like if in general, if you have a number that divides, so if you have any number like x that divides AP, right? And x has GCD 1 with A,
It doesn't divide A.
then x divides B. Yes, that's also true. You can prove that as an exercise if you want.
Unless I could see.
Huh?
Unless it's
Yeah, but we
Well,
already
one
said
does
that.
divide B.
Yes.
no, but I didn't think about it.
The GCD 1 with A is
Yeah.
still 1.
Okay.
So it works. Okay, so look, we have r squared divides a squared, right? So that means that second r has to come from this 2p plus r. Because r is not coming from p squared,
Yes.
right? We're assuming p and r
So
are
R
different.
has to divide 2p. 2p plus R has to be a multiple of R.
Yeah.
So that means 2p must equal some kind
So that means r must divide 2p, right?
Yes.
Yes? Okay, I don't like answering people's questions just because they haven't listened, yeah? That's annoying.
Yes, that is.
Yes.
I can't be too because it's the largest one.
Yeah, exactly. So if r divides 2p, right?
Yeah.
I see.
Well, then R can't be because R is the largest prime.
That's a problem, yeah.
That can't work.
But then,
I mean, yeah, 2p, how can it be a multiple of r, right?
Yeah,
it
I
can't be
know.
2r, right? Because p is smaller than r.
but then I.
It can't be
Can't be R.
can't be r.
Because PR is a prime.
Can't be too close.
It can't be 2R because R, that's not
P
equal to
equals
R.
Q.
Yeah.
And it can't be R because R
This
is
is a problem, yes?
R is a prime.
So it can't. So this can't happen either. So the only thing that can happen is p divides p plus q plus r, and then they're all different. Yes?
Yeah. Is it necessarily?
So if they're all different, this is the last case, right?
Yes. So unless you messed up somewhere, it must be true.
Okay. So then p divides q plus r, right? Yes.
Oh yeah.
Because like you just subtract the P. Doesn't matter.
Then P equals Q. Which is
So what happens? So q plus r can equal, let's see, you can 0p, 2p, 3p. Is that right?
Yeah.
Can it be any of these things? So q plus r, they're both bigger than p, right?
So it must be equal to at least 3P.
Yeah, because of all P.
Or bigger than P. So it must be at least from 3P onwards.
How can't it be equal?
So is that a unique
But
solution?
then it can't be equal. Wait.
Or is it the minimum solution of P plus of the P plus Q plus R?
I feel like I'm missing something obvious.
You are? So what? So is P plus Q plus R a unique solution, or are we finding the minimum solution?
Oh, hold on a second. So in the case that they're all different, right? I mean, I guess it would be simpler if we said, so if they're all different, right? Then it might be simpler to consider the case when r divides p plus q plus r.
then you get P plus Q.
Yeah,
R
that would be a problem then, right?
Huh?
I'm saying if you're just considering the case where they're all different, right?
Yeah, because it's no.
Yeah. Then I think it might be more conclusive to see what happens if r divides p plus q plus r, right? Because then r has to divide p plus q.
Oh.
Yeah. So that limits the possibilities by a lot, right? Because now p plus q can't be like p plus q can't be 0. It can be 0. No, it can't be 0. Like it can't be 2r, right? That's the point.
Yes,
It's less than.
Because they're both less than r. Yeah.
Yeah. So it has to be R.
So p plus q equals r.
Yes.
Right?
It has to
Wait,
equal.
why?
Yeah,
Because any other multiple
Oh,
of r will make it
Oh,
bigger than p plus q.
Oh, okay, that's obvious now. Now it's obvious.
Yeah.
So now that becomes 2R times. It becomes P plus Q becomes R, so that's PQR
2R, yeah.
times 2R.
Why
Yeah.
did P plus Q is multiple?
Because I'm saying r is so like all these 3 primes, right?
Yeah,
Divide the square.
yes.
So r has to divide the square. So r squared has to divide the square, right?
Yeah.
So so that means r has to divide this.
The rest.
Yeah.
Because the rest has to be have a multiple of r in order for the square to be matched.
Yeah.
Because they're all uniquely prime. You can't split them. So that makes sense. Now it's
So I guess we're actually breaking it up into the cases where they're all different, 2 are the same, or 3 are the same. Yeah, that's the cases we're breaking it up. We're not breaking it up necessarily in terms of p divides that, and that.
Yeah.
No. We come to the same conclude, like the same place from considering those cases.
so p plus q has to be equal r. Has to equal r. So now I think we get the solution right away.
Yeah. So p plus q is equal to r, right? Okay. Then that's 2r. So that's 3r, right?
How's it
So
3?
sorry, 2r. 2r, yeah.
Yeah, times
Times pqr.
Well, that's 2r squared. 2pqr squared.
2pqr
So
squared
the r squared cancels.
equals a squared. So you need. Wait, is this?
Are you finding the minimum value of pqr?
Hold on. Should I be getting a contradiction still?
Well, you shouldn't.
Or was it that? Was it
you're
when?
missing like there's one case you're missing.
Was it the when they're the same, right?
So r might equal to q.
Oh, you're missing the case that
Oh
p
yeah, that's
is.
right. Yeah.
There's
That's the
4
only
cases.
Yeah. So this case is a contradiction. Yeah.
Yes.
Okay. Good. And then
Because they're all primes. You
Mhm.
can't have
because now we have
2pq, and they're all primes.
There's an
One of them
odd
can-
number of primes here.
Yes.
See, there's 5 primes here. There needs to be an even number for it to be squared. Yeah. But that doesn't work.
That's a contradiction.
Okay. So there's one more case.
There's 4 cases.
Yeah, sorry, if I'm bringing it up into these cases, I've got to consider the case where 2 of them are the same and it's the bigger 2 that are the same, yeah? So P is not the same as Q, but it's the same as R. The Q and R are the same, yeah? Okay. So if Q and R are the same, then, yeah, so PQ squared, and then this is P plus 2Q, right? Equals a squared, yeah? Is that right? Okay, so P has to divide this, yeah? Because
Oh,
P
yeah,
divided
that
squared,
has
there's got to be 2 P's, right? So the other P has to be in here.
So p has to divide
2Q,
2q.
yeah? So then P has to be 2.
Oh yeah, true. Because p can't be anything else, or else it has to be prime. So
Yeah.
p has to be 2.
Does that make sense? Yeah, so P has to be 2. Then Q,
And then we
Right.
have 4 plus 4q.
yeah, so 2Q squared.
We can eliminate the q squared.
Oh, well, we need to know, hold on. So 2Q squared times 2 plus 2Q equals a squared, right?
So we can have 2 times
So that's
4q squared
4Q squared
plus 4q
plus 1 plus times 1 plus Q equals
a
a
squared.
squared, right?
So we know that 4q squared is a square number. And
Yeah, so
that
we're
means
basically-
1 plus q is a
Can
square.
you see that at this point we're looking for a square number that's a prime plus 1, yeah?
Which is 3.
So can you see, like, it's not easy to get a square number that's 1 plus a prime. Yeah?
Yeah.
Right? You know how to see that?
Yeah.
But then Q is equal to B squared minus 1, right? So that means B has to be, yeah, so B has to be 2. One of them has to be 1, right? Or the product of them both has to be 1.
Yeah, well, we can just substitute the values now.
Yeah, so either B equals 2 and Q equals 3, right?
Or b equals. You can't do anything else because q has to be prime.
The factors of primes that you wanted.
So Q is
B
3.
plus 1 is Q.
So the value, so the final answer is P equals 2 and Q and R equals 3. So in the end, you have to check 4 cases.
So was it P equals 2, Q is 3, and
Q and
R
R
equals
equals
3.
3.
So then there's only one sum, isn't it?
Yes, it's not a middle.
Is it 8? What?
Yes,
Yeah.
it's the 8.
That's why I got.
Huh?
That's why I got.
Okay. So we did this one before. I couldn't remember it, that's all.
No, this is hard.
Huh?
It's hard.
Yeah. So I guess the thing is like, if you try it and get it once yourself with this kind of reasoning, you'll find it much better. It's obviously harder to follow someone else go through it, right? Because you don't know where the turns are coming from. Whereas if you do it yourself, you'll see that there's one crucial point where you come up with that idea, right? And the rest is basically a follow through. Yeah. Okay. Well, I need to do some bookkeeping, guys, because I need to figure out what you guys are up to. So in this book, okay, if you've been keeping up with the problems so far, there should be like 5 or 6 more interesting problems in this book.
I don't even have that book.
Well, I'm sending you the problems. Yeah? Okay. So I don't know if you guys want to go through that, and then there's the exams. Yeah, I'm gonna make some notes for you for next week, which go through the exams. But like, I mean, I just know which years you've done. Yes. So there's the exams from 2013 to 18. Yes. So do you understand? Next week, next Monday, we're gonna talk about 2018 exams.
So you have to do that before.
We have to do it if you can under exam conditions before you show up. Yeah. You understand what I'm saying? 2016, 2017. So 18 is next Monday, yeah?
Yeah.
Okay, and then I want to know who's done what. I've got some spare copies of some exams if that helps you. But can you tell me which ones you've done?
I did come with it.
I'm just no one comes over to me. I didn't come last Wednesday.
I did come
Or last Wednesday.
Alright, so who hasn't done 16?
Me.
Huh?
And we're just 16 together.
So you might have done it, yeah? So you did it, yeah?
I did 16, 17, 18.
So you've done 16, 17, 18.
Yeah.
When did you do 18? We never did 18.
Last year.
Yeah, he did it last year in the actual test. So you did 16, right? You haven't?
What, that?
You don't have to look at the question.
Oh yeah, I did a question that's why I did it.
No, we did that.
When did we do that?
In the holidays.
This is the second week probably.
Oh,
Yeah.
You did that, right?
I did.
Wait,
You did
was it,
16 and 17.
so is that literally in the exam? Would they literally
Hey,
give you
oh
a sheet?
yeah, I just drew on the Pentagon.
So they'll literally just give you a sheet.
No, there's a answer sheet where you write in the answers, and then they also give you paper.
Okay, so Sean, you haven't done 16, yeah?
I can.
Which ones have you done?
I haven't done 16, 17, 18, 19.
13, 14, 15? You've done 13, 14, 15, yeah? Sing, which ones have you done?
Me?
Yeah.
I think I've done the earlier ones, 2014.
So you've done 2014
and 2013.
and 2013? Okay.
Can I see what they look like?
2016, look at that.
I did that one.
Yeah, so
You
you've
can
done
see
that.
it.
Have you done this one?
I've already done a few questions. I don't know if I one.
So a lot of this, hopefully you can go through on your own because I have it all written down and videotape and stuff. But if you have some problems, you can bring it in, yeah?
Can I see 2013 and 2014?
Let's see if I have it. But so, can you put this somewhere? You can, or I can send it to you.
This.
Yeah.
Okay.
Try to do it on the
Are you
exam,
sure you
but
don't
you
have
don't,
a number 3?
don't look at it. Don't do it.
I did.
Don't read it.
I did do this.
Question 9 is really easy. To be honest.
Okay.
You said draw.
So you haven't done 16. Don't
I
read
just
this.
drew
Put this away.
it.
This one, put this away.
I haven't done 14.
I want to see 14
Or
also.
17.
14 is Korea.
Did I do it?
I did it.
Oh yeah,
I
right.
just
Is that which one is that, Hype?
Can you not talk about it? Like, come on.
Oh no, I'm talking about the one that I didn't do. Like asking which one was it.
Are you guys still connected to my stream?
Yes.
Huh?
We are.
How?
No, I'm like, I have like zero data. He is still connected. No, he's way too far behind. He's no longer live in the stream. Okay, now he's live.
Jesus. You guys are so immature. Really? What year is this?
Huh? It's not live at all. It's
It is live.
down.
Wait, you
It's,
have
it's
to
from the
What
infinite
is
root.
this? What are the bonus marks? Is this even there?
No, it's
As of if you don't look
no because no, it's video stream or video
Well, what
stream
are
or
the
video
bonus
stream or
marks?
video stream.
Right, who's done 2014? Where's
Can I
that
see it?
list I have?
Can I see it?
So you and Sean have done it, yeah?
Can I see it?
Yeah, it's infinite.
Yes.
You've done it?
I haven't done it.
Is that the one where there's at the back there's like a tile thing?
Yeah.
Yeah, I've done that.
Alright, don't read the questions. Save it for under exam conditions.
Just look at the picture and see if you remember.
Wait, don't read it.
Funny thing is, I've already done like one question of every single test.
Which
It's
is
annoying.
So you've done. So you said you've done 18, right?
I think, yeah.
you didn't ask
No,
me.
I did all the
17.
questions except for geometry. I'm really bad at
So you haven't done any of. Which other papers have you done? Who's done 13? Have you done 13? You've done 13.
see.
I haven't done 13.
Yes, 13.
I haven't done 12, 11, 12,
13.
17.
No, I haven't done that.
You haven't done it.
Done the 1999 one.
I've only done question 4. And I've done question 5.
Yeah, I haven't done this one.
Yeah,
Have you
like-
done this?
So I just gave you that. So come on.
I have all the test papers from 1999 to 2018.
How?
Alright, guys. So we're gonna go through question 2018 on Monday. Yeah.
The one that he did.
Yeah. So if there's other stuff you're interested in, you gotta tell me like before then or like on Monday. But then for the afterwards.
Where's the test again?
This is on the the Monday we're meeting for 2018 is September 2, right?
I think
Yeah.
have you paid?
Yes.
That's next Monday.
Have you paid it?
Yeah?
Yeah.
Can you listen to me? If September 2 is a Monday, the payment is irrelevant, okay? September
Really?
2 and then September 9 is the next Monday. And we don't have any more Mondays. And September
Wednesday.
12 is a test, it's a Thursday.
So we do it on Wednesday.
Oh, so we have
Thursday.
like, we have like 2
Well, I mean,
more
like,
weeks.
so we have.
You can come here on Wednesday. Yeah.
I did.
But I mean, we're not gonna go all out on Wednesday. We're gonna be resting a lot, mainly on Wednesday.
Yeah, because like you don't want to get
Resting.
tired on the day
Resting,
before the
honey.
huge exam.
Resting on Wednesdays.
I don't know.
Yeah, I'm still lying.
Wait, what do you? Wait,
Yeah, me too.
Well,
wait. Can you get prizes and? So how do you get prizes
that's
and
like the
medals?
rest.
How does the prizes and medals work in there?
If you get 100%, you get a prize.
If you get above 30, it's prize.
Oh, wait. Then you can only get like one question wrong.
well, less than questions.
Maybe. You can get a question.
Like if you have a 2-mark question, you can get it wrong, and then you get another 2-mark question wrong. And then they're just wondering, well, why are you getting these 2 mark questions? He's got some kind of like weird hack where you sacrifice a 2-mark question and you get a 5-mark question.
Then wouldn't it be smart to like do the 2-mark question and do part of the 5-mark question? Because then the 2-mark wouldn't take
What if you got it wrong though?
Oh, that's so sad.
How did you get too much wrong though?
No, I get multiple choice questions in my school math exam wrong. It's nothing special.
So how do you get
Like the ones that the very basic.
Why is that so tangled? It's just tangled, isn't
it's not tangled.
I've seen much more tangled.
Okay, I don't have any copies of 2015, but like, who's done it and who hasn't?
I
it?
don't know
Combine
this.
it up.
We have?
Yeah,
Like,
pretty
at
sure
the
you guys
start.
have.
I mean, at the end of
Okay,
it.
so Sean and Kavan.
I think we did good in that one, right? 24.
Oh, we both got 34.
Yeah.
Is that
What is-
good? I'm pretty sure that's not
That's
good.
high distinction, isn't it?
Are you sure?
Yes, 24 is high.
Yeah, so do you guys know what the goal is? So we have like basically like
That's so small.
5 or 6 problems left in the book, and then we have 6 years worth of past papers to get through. Yeah,
Yes, that's a lot. Enough.
in 2 weeks.
Yes,
Yeah.
that's enough.
So if you don't actually set yourself a schedule, like basically by Wednesday, or you can even come on Wednesday, but like if you don't set your schedule by then, okay, you're like setting yourself up to fail, okay, because there's a lot of work to get done, and you want to at least be prepared to not get a certain amount done, you know, as opposed to think you'll do it, not even plan it, and then like
They're not
do
doing
like
it.
2 of them and be really disappointed, right? That's a terrible outcome.
The sad thing is, if you do the past paper now, then in like year 9, then you're having past papers.
But in year 9, we're not going to be focused on this content.
We won't care about the AI, but
Yeah.
Oh.
Because it's the AIMO, intermediate.
So if we get this done now, right,
we won't care about.
we can work on
Lightweight.
like we work on senior contest, or we can AMO, yeah, tournament of towns. You know what I
Is
mean?
that one hard?
Well, can you focus on this? Yeah. It's like- but if you don't do it and you kind of just don't learn anything the whole time, then we will be doing AIMO again.
And then you will have past papers.
Yeah. Yeah. But the past papers is like it saves you from going to that year and not doing well. You know what I mean? So it's like 10 years of AIMO, and now you've right. You know.
Was last year's one hard? Was it?
I get banned on Steam.
Well, it's weird because no matter how hard or easy it is, it's the same cutoff. It's the same cutoff.
How? Why? How and why?
I mean, it could be easy, but it could also take a long time to finish. You know what I mean?
Yeah.
Like there could be a different element of difficulty.
Depends on like.
Just
All the
if
people
you-
who finish
I
and
left out
like,
10 hours.
all the people who found it like easy that year, it's like leaves the next year. And all the people in here are just like other people.
Yeah. Okay, so I got to think about 2015 for you guys. 2016. Sure. Leo, so you've done 2016, yeah? You have it at home.
Yeah.
He
Well,
has
did
everything at home. He has a
wait,
book.
did I give it to you just then?
He has a book.
No, you gave it to me.
Don't you have a
Oh.
book? Why are you taking it?
Yeah, so Leo, have you done it, or do you want a copy of this? 2016.
But I think he has a book. Right?
I think no, it goes up to 2013.
The book only goes up to 2013.
Yeah.
Okay, well, in 2017, I don't have any copies. But who has it and who hasn't?
Yeah.
You have it?
Oh,
Done
I
it?
don't have it.
But I have 2013, 14, 15, 16, 17. It's on the website.
But I
They're on
haven't
the
done it.
website, by the
I
way.
haven't done it.
So Kavan's done it. Have you done it? 2017.
Oh, look, can I see?
Are you sure you didn't put that one in?
Because I don't know. I haven't been here for a long time.
Yeah, if you do it really well, I can get you to teach other people to do AI.
Oh, really?
Wait,
Teach
teach
us
us.
to-
That's 17.
Yeah,
That's 17.
My goal is to get a distinction.
I don't have
No.
17
Go should be high distinction.
copies, but you can see it.
Do you think you'll
I
get
don't
it?
have spare copies.
I can get it sometimes.
Oh, actually. Oh no, I don't. What is this?
You're a snowball. Very nice.
You know how trash no one fucking
I didn't do it.
Did he
Huh?
miss that? But yeah. Probably a car. Watch.
It's not how I do that.
What?
Your mom.
Yeah. I mean, you could also take a photo of it if you want. 2017.
Yeah. No, I got like 3 movies. I'm trying to.
Well, might have been one. I just remember this question was
I
hard.
got.
Yeah. Oh, guys, so there's going to be some communication, yes?
Why?
So one-way emails are nice, but if you have some adjustments, questions, reply, yes? So we can organize next week. Like it's better to like adjust the plan according to the 4 people we have, right? As opposed to have this general plan that never changes all the way up to the exam. No matter how the people change, right? We only have 4 people. We don't have to do a general plan. You understand? It's 4 of you. We can focus specifically on each one of you. Oh yeah, but I mean,
Hybrid doesn't count.
well, Haibing has.
You can get like a friend.
Is hybrid doing the Aimo?
Is he doing the AMO?
Yeah.
Is he doing the
Haibing's helping me help you. Yeah.
Oh, so hybrid's
Wait,
gonna get
so-
prize.
Do we like?
So Haibing won a prize last time we did this competition.
Is he gonna get prize again?
Well, it maybe not, but like it does. It's kind of like.
When's the last time you did that? Last year. Also, like.
Might
But you know,
go.
it's kind of it once he's done that, he can move on to other things, right? Now it's proof contests, which will slow him down for this. Just like how it's slowed him down for the MC, but like it will slow him down. But like the point is, the things which this test gives you access to, he's got access to, right?
Oh, bad.
No, it's fine.
Are you sure?
No, just don't worry about it. Like basically, just go through the questions. There's no pressure. You gotta enjoy doing the problems, the challenge of solving it. Maybe you fail, doesn't matter.
I do.
You go through the
enjoy-
process. By the time you get to the exam, like if you've
They
done as best as you
Day
can,
and 2 days before the exam is day.
yeah, like if you just the day before, they just rest, right? But like as far as your mind is concerned, right? There's no point worrying if like you're gonna do well or badly. It's more like important just to worry about what your next step is, right? Do the problems. Once the time is up, you've done the best you can do, and then it's out of your hands. Yeah, and then that's the best feeling.
Oh, so I shouldn't leave.
Certainly not.
Had to leave early.
Leaving early is like it's a
The
sign of
worst
giving up. Yeah?
Decision.
Unless you're doing informatics.
I left 3 hours early
Because
last time.
informatics is like
Wait, what?
I left 3 hours early.
Yeah, yeah.
But he was in year 7, so
I didn't invest out of first 5 periods. So like,
My school didn't even.
I do enjoy doing these problems.
yeah.
I
So
don't.
focus, okay.
My school doesn't even.
We're all gonna get 4 marks.
For some reason,
Yeah.
Q still
Wait.
takes.
I
It's
asked.
still taking a while for my application to go through.
But I mean, if you think about all the things that you have to prepare just to eliminate all these random little variables, you don't have time to worry about failing or succeeding. You know, there's always something important to actually think about. It's like,
Yes,
oh,
if
when
you
am I
think-
going to wake up?
it's
What am
like-
I going to bring?
It's like the
Let's see.
opportunity cost of thinking about doing good or doing bad is already making you do worse. So
Yeah.
there's no point of thinking about it.
I still want to die.
It's just the
Or just by thinking of trying to do that to making yourself.
the same bad.
I should be thinking.
Focus on the question. You know?
Yes.
Focus on the time. Focus
So
I
what-
never think I have time. 4 hours.
I do enjoy doing the problems. I don't enjoy doing these, but however, I don't enjoy doing them or having to like work till like in the one to finish my schoolwork.
It's not.
Yeah. So I mean, for this
I
2 weeks,
promise you
hopefully
I'm
you can
really-
somehow get
Have you never
answers.
done like one school exam?
Oh
Yeah.
yes, I can.
My-
I've
the longest
disregarded
I've done
every
exams
subject
when I was
except
young.
my core
Yeah.
subjects I'm doing next year.
once I do this, I'll be free
I've
until
never
next
done 4
Friday.
hours straight.
Because next Friday, next
It gives you
Thursday.
cancer.
It's like at the same. Well, I think it's.
I mean, I can't do that at home, but if you
Because
do it,
Yeah, if you do it, you do it.
I like- I
If
would
you
be like
do it,
saying
you're
like
like,
that.
you're not gonna be.
I
You're not
can
gonna
probably
do
just transfer that after
Because
the.
you
Yeah,
can't.
It's a 4 hours here.
Yeah, just do
Alright,
4
cool.
hours here.
And avoid this.